So I can get done with that on that. Good morning to you all. Hey, artist, how's it going, man? Go. So we'll be in. Got our definition here. Probably bring up a test window. Yeah, we should be good to go on that. 88, that's plenty. I don't need that many. Actually, I'm probably pretty fine with it. Split. That's right, I forgot I changed my font size. Hope everybody can still see it. Hey, Gaming Weasel. Yeah, I know there's a lot going on, I know. I had to pare back on mine too, but this is one of the most important ones, so I'm going to go ahead and spend time on this. I think we're getting close. I always think that, though. So it always feels like we're getting close. So the main function is in here. I did this a little bit yesterday. Parse and handle. Okay, so we had our error handler built into here. What else? So this is the one we have to, the main parse function. Parse and handle, back to parse and handle, blah, 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 blah. AST root underscore parse. And then we set root to be octal, I believe. So I think this just needs to be tested now. In fact, I think we put it already in our defs.go. Yep. We got our octal here. We set root to octal. And yeah, and then the reason for this is so that we can give instructions to people who are using the generated code and say, hey, just set root to whatever. And right now it's set to octal. So that way I can change the tests. In fact, I could change it. In fact, I could use it to write individual tests. Oh, I hadn't thought of that. Actually, this is going to be fun. So, how's it going, Q Macro? For a short break this week from the English Lake District. Nice. All right, so we're going to be doing this scanner. So we have this test here that I'd written already. I'm trying to figure out if that's the best place for this test or not. I don't know. This has already been copied over, so I can delete it now. I think I got all of them. Let me make sure I got them all first. Oops, sorry, Go. Didn't mean to leave you hanging there. So we have an octal, an octdig. Oh, well, yeah, we're missing oct range. Let me go ahead and get oct range in there. Copy that one over. I described a lot about why I organize the code this way in other streams, so I'm going to try to avoid it. I'm going to try to save my vocal cords, to tell you the truth. Yesterday, I was talking straight for like 6 hours straight. It's like hard on your vocal. I'm glad I don't sing. Actually, was friends with a Broadway singer, and she, yeah, I mean, she gets sick just even a little bit. She would have to take a break. I'm not a Broadway singer, but anyway, octal.parse. So yeah, I think this is a pretty solid example. I'm pretty sure this means that I can remove underscore defs now. It's funny because I just copied all that stuff over, didn't I? Remove underscore defs. And what else we got? Def test needs to be changed. And I don't actually know if it would be a good practice to have in the generated code to generate tests that go with the code. I don't think that's going to be needed because they're going to be, other than for code for test coverage, I guess we have to make it. Okay, so that's decision just got made for me. So anyway, we have a def and a defs. What is a def? A def is a single definition. You know, I could almost get away. What are you doing there? You need to go away. Let's see. What is JSON underscore test? I got stuff that snuck in here, and I'm trying to figure out where it came from. Is that just me being dumb? I think it is. Oh my. Oh my. How long has that been there? Test.go. Undefined pegn and defs. Yep, well, that's because I moved that one over. Let me just take care of that real quick. So I don't need to prefix anything anymore. Get these out of here. I should fix that error. I was afraid of this. So I've been paying attention here a little bit more. You know, let's just change def to definition.go. Did it work? Nope. What did I do wrong? Oh. Man, better wake up. Hey, return to dust. How's it going? So we have definition, and then we have def underscore test. And that can be fine. We can probably leave that there. All right, and then we have defs. Now, defs is the file that's going to be auto-generated that sets root. And so yeah, let's do that. And that root thing is going to allow us to write some test cases that test individual definitions. I do have another error, though, in the JSON package. I might as well spend a little bit of time fixing these. Hopefully it's not too long. Package def, pegn, and oh boy. Oh boy. There we go. I should be happier. Defs.go. I thought I got all of you guys. Nope, guess not. Oh boy. That's, you know what? That test file was not properly named, and now it's going to make me want to go test the whole thing. Which I don't feel like doing right now. Because I'm still working on the parser function. Frankly, I don't need that right now. So I need to put that in the to-do here. Got the scanner implemented. Need to start the generator. Clean up JSON test.go and finish the finished first pegn.parse. Testing. Just make sure that's all working, and then we can put our scanner in there. It should not be a problem, but I got to turn off JSON test for now. So it will not pick up anything that has underscore in front. So I'm going to move that. I'll turn testing off. Assuming that I've touched another file, it should. There we go. What next? How's it going, Killbots? And so defs.2020, we got this. So this file is generated, and we're going to start out by testing how we test. And I think this is something we can do in def test and defs test. Def test is actually unnecessary at this point. So I'm going to remove that. And we're going to make a defs test.go. And inside of this, we're going to start, let's see. So, would be auto-generated along with defs.go. I just want to make sure people understand that what I'm doing here is just sort of proofing it out. Before I move on to the generator, I want to be really, really sure of what it is that we're making a generator out of, lest we waste time, right? So yeah, and then I have a feeling I'm going to use example-based tests here. I don't know if I need them though. If I use example-based tests, no, these are all private, so I can use example-based tests if I just like that better. It's just easier to write example-based tests. It's just so much easier to have to write the if statements or anything. So I'm going to go ahead and keep them, even though these won't show up in, because it won't be associated with anything because they're all private. So I think I can pull that off. Let's try it. Func example. I mean, let's try octdigit. Octdig. Output. I mean, maybe I will use regular tests and not these. Who knows? You know what? Let's do actual test cases. Shall we? You know why? Because then I don't have to prefix everything. So test, and there's no thing that has to come on it or anything. Test octdig. Okay, so plus I got to tell you, I get a little bit rusty on the built-in test framework because I love the example test framework so much. Which means I should probably pull up this spec on Golang embedded testing, the testing package, because I don't use Testify. There's lots of competing third-party things out there. Just a quick overview on testing if you don't know about testing in Go. So there are three types of tests that are built into Go. There's the regular tests with test as the prefix, where XXX does not start with a lowercase letter. The function name serves to identify the test routine. So this is just the name of the test routine. That's so you can match it when you want to isolate your tests with -run when you run the tests. So if you don't want it to test them all, that's it. So it doesn't have any significance beyond that. Then you have benchmarks, which I don't know why they put that second, but you have benchmark tests. These are more verbose because you have to check against things, and you can send an error, and you can say want got, and this is why people make third parties, because all this extra scaffolding is really annoying to write. Benchmarks, which test performance. I did one of those 2 days ago if you want to go watch, just to kind of test specific things. And then the example-based tests. So the example-based tests, here you go. They have a very specific format. The stuff that comes after the word example matches the function or struct or whatever. So salutations, right? And then example form. And here's the convention. So you have just a general example will just test whether it compiles or not. You have an F for testing a function, a T for testing a type of any kind, and a method of a type you do like this. And then any underscores that are provided after that, such as this, can be done. And this will be capitalized, and all the example tests will be added to your documentation for free. So that's why I like them. They're also a lot easier to run. And you can actually run setup code and then run individual tests with the function, blah, blah, blah. These are all things that I've done in the past, but you don't need that unless you're doing a lot of individual tests, but this is why you would do the name. See, it does it matches all the test case there. So yeah, you can group the subtests and run them all together, blah, blah, blah. You can even do parallel tests, which is pretty crazy actually. Yeah, for race condition checks and everything, you can build it into your testing. So, and there's, if you run -race or whatever, that'll check for race when you run tests, but otherwise you can just put them in your test case and check for that. All cool stuff, by the way. It's really one of the main reasons I like Go. So what do we got? We have a init that runs the thing. Main. If these are all, you can go big if you want to on this stuff, but I just want a couple of simple tests. Oh yeah, I forgot about coverage. You can do test coverage. I haven't used this very much. I usually just use the coverage tool. Current code coverage at a fraction. If coverage is not enabled, coverage from 0. Checking coverage after each one can be useful for identifying which cases exercises new code pass. Reports generate. I was going to say it's not a replacement. Interesting. I haven't played with that one. I mean, there's a lot of like nooks and crannies in the testing package that I don't need because they're not practical. But these ones I definitely do. Hi, Greg. So fail now, fatal. We have log. Logging is a great way. If you do -v, it'll show you your stuff. So if you just want a simple test. Something important is the difference between fail and fatal. Fatal will stop all the testing. Fail will just, fail on that error and keep going. So that's kind of nice to know the difference between that. All right. So yeah. It must be blah, blah, blah. Wrong signature, def tests. That's a different thing. Let's go see what's going on with that. I don't think I have a def tests anymore. Do I? Oh. I do. I just made it. Duh. Wrong signature. Okay, so it needs this. That's what it needs. Octig. And so, yeah. Test octig must be function blah. Oh, yeah. Duh. I'm actually going to keep it like this. See if I can pull that off. Mostly because I don't want to have it. None of these names are needed for anything except for regex matching for when you're doing your testing. And there's actually the difference between classes and stuff. All right. So that just fails. So this test, we're going to go ahead and we're going to make, in each one we have to set the root. In this case, I'm going to set the root to octal. No, octdig. And then I'm going to just parse an octig with the scanner. So I have to initialize the scanner. So scanner, again, make a new scanner. I need to check something though. I want to see. Yeah, I was afraid I do have to do that. I probably have to make a defer in here. I should probably just do one for all of them. Since this is not a public test, I can do that. So we're going to go ahead and just put one here. We're going to call this, we're going to call this, God damn it, func handle panic. Oops, don't need you. New scanner. All right. And then, so yeah, we should have a defer in all of these. Defer, handle, panic. I should probably put some testing in there as well, but for right now I'm not going to do that. I'm going to do t.log also, t.log. Crap, I have to pass the test in, don't I? I don't want to do that. Fuck it. I'll just use, I don't know. Ask the card or not used. I mean, we can probably check that out. I could use a trap that would kill parallel tests if I wanted to. So anyway, I'm just thinking about some other ways I could deal with the panics. Panics are a little hard to test, obviously. So yeah. Is the clip not used? All right. So s.init, and I need to give it something. So give it some data. Let's give it its 34s. Actually, let's do 34. Blah, blah. Oct, wait, oh yeah, we're testing parse here. So that's why I want to do it this way. I mean, I could individually test every one, but I want to test if the overall main parse function is working. So parse, see what I'm doing. Yeah, okay, so do I have parse string? I think I have parse string. You know what? What are we testing here? Parse. Testing parse. It's in the pegn thing. I probably should make this its own thing. This is parse match validate. Yeah, these are all the main top level functions. I think we're just gonna use parse. Parse string. That's what we'll do. Easier to do. So parse string. I just need a scanner, and I think I'm mixing up my parse methods. Let's see. I should get an expression and an error back. Okay, so, and I'm cheating here, just so everybody knows, by setting root. So normally when you call this, normally when you do this, it would start the top level and root would be set to grammar. But these are all private things. It's another reason for me to use an internal test, because this is kind of stuff you couldn't do in an example test. You have to pretend like you're the user. So we do need to make a scanner. I don't think we need to make a scanner, actually. That's the whole point of this. Parse string 3, 4, 6, and that should give us an expression, a PEGX, and an error. I'm doing like Python shit here. Do that like that. All right, and then what? PEGX decoder not used, of course. If error is not equal nil. I mean, this is why I don't like this kind of test, but oh well. T.fail error. Too many calls this fail. What? What? I can't remember how to pass the error to fail. I think it's a W. Oh no, there we go. All right, so and what do we do now? So then we do this. We do PEGX. So PEGX, we have to check the PEGX. So for right now, I just want to see what's in it. Actually, no, we need t.log for that. T.log PEGX, which is a rooted node tree, so that should print in log form. Formatting directive :v. It has possible formatting directive fail. Where is that coming from? Def's test. Oh yeah. Invalid memory address or nil pointer dereference pass. So that was a panic, and I trapped the panic and didn't get all that ugly crap. No pointer dereference. All right, let's put one of these on here too. Makes the errors much easier to read. So yeah. Anyway, obviously, I'll probably need the trace on that though. Let's turn defer off for a second. Why are you not blowing up worse? Oh, because it's coming from the other thing. That's coming internally. Yeah, that's coming internally. That's not getting trapped here. That's getting trapped inside of the parser, which is a good thing. The scanner parse thing. Oct dig. So I wonder if it's just one. Nope, got another error there. So this actually should work. So let's go see what's up. This is why I wrote that, so we can make it work. Test-driven development. Let's make sure it's actually getting into the octal dig, the octdig. And it's actually, oh, look at this. There is only a scanner for octdig. There is no parser function at all. Well, no wonder. This makes me reevaluate something that I've been considering. And it's related to this is related to the spec itself. So the these things here, here's our octdig here. The idea is that this is just a class of characters, you know, the characters are the runes 0 through 7. And therefore, doesn't need to ever have a parser function. Now, the problem with that is that, you know, what if you ever decided later you wanted to parse it? Well, that, like, all you would have to do for that is put a dash here, by the way. So I want to have a parse function for this. Then, yeah, you'd have to do that. In this particular case, so we have an octal which has an octdig in it, right? And it has a parse routine. And it actually scans the octal digits knowing that it can't just call parse on the octdig because it doesn't have one. So I'm trying to think about, in terms of code generation, how that would happen. I would have to say, okay, this is not significant. The thing it's using is not significant. Therefore, we're going to just have to scan a bunch of those classes and make some rules about that. And I'm totally fine with that. But that means that my little test here has to have something that can be parsed. And so that's going to be more of a parse octal. Right. And so yeah. Expected O at 0 bypass. So see, there we go. And now we get what we would expect. Look at that. Look at that beautiful error right there. And that's what we want. In fact, if I were to put a 0 here, it'd probably be successful. And we get a pass. And I'm super happy. In fact, I'm so happy I'm going to get more coffee. So everything is working as planned so far. And we were able to set the root and get our pass. So we're about ready to make our lookup table. And I think, but so the only other thing I want to test here, I want to test oct range as well and see if we can get that. I need to flesh out this test suite right here. I need to not just log it, of course. I need to do something more with that. I'm curious though. Where was that error generated? Where was it generated? Actually, I shouldn't have any panics in here. What am I talking about? I don't need to trap panics. They're already trapped for me. So, yeah, there we go. So we can put a print made in there. Oopsie. Yep. Ah, interesting. It didn't send an error. Huh. Interesting. I never made it into the error code. You know why? Because this panicked, trapped it, but I don't think it's returning it as an error. Very curious. Curious. Huh. Wait. Wait. What? What the heck is happening? I still have some errors getting printed out and I'm not doing anything. This means that there's a panic that's getting trapped. Oh, you know what? I think I know what it is. So the default panic or trapper thingy is doing it. Yeah, there we go. It's just this printf error, the default parse panic. And that's why there's no, yeah. And actually I'm going to do this. Because this is like user, actually no, this is userland. This is not userland. Userland is like the application that's running this thing. So yeah. And I don't think we're gonna persist the panic there. We don't need to. However, we do have a problem because the whole point of having an error there is so that we can return an error. We can't return the error because it's jumping all the way to this function. So this error is never returned. That is a problem. That's a problem. That's actually a problem with exceptions in general, by the way. But panics are really bad because they jump all the way out of the function. So you can't. The only way to get around that is for me to return some sort of thing like last error or something and grab it from the package namespace, which is disastrously bad. Yeah. That is not okay. Interesting. So this panic approach has got a quirk on it. I'm going to go get coffee and think about that. We just hit that, though. We wouldn't have hit that without that test. So error is completely useless. This thing here, this error is never used because it's never returned because we're handling the panic and trapping it. So it doesn't ever get a chance to return. You know, any one of these things blows up. It never hits to the return. It never gets to the return line. So yeah, because like this defer handle thing, so let's say we get to this line here and it blows up or something, then it goes up here and just completes and it's done. It never returns control. It never returns control to these returns. In fact, the returns are just show at that point in case the whole thing works. So returning error is a waste. And we probably just need to document to trap the panics on this stuff. And that's our method. Some people might not like that, but any encoding JSON library does that. So yeah, leave this code up for a second. So, what to do with that? Well, I could put defers in each of these functions and not write them up here like this and not be able to pass the handler. I think it's okay to use this panic approach since we're using parse and handle. Because why? Because we are passing a function that can be a closure for something else that has other data in it, that can run and people can do whatever they want. But if they don't want, if they just want it to fail, they can do this. Now, the default handler obviously should set some sort of error, but the only way for that error to be communicated would be to set it on, well, since these are functions, the only way for that to be saved would be inside the package space, and I don't want to do that. Because it's, it's non-functional, it's going to be like, you're going to be checking, I mean, it's just like, it's a total hack. I mean, so for example, if I, instead of printing this error, I mean, I'm trying to think here. Instead of printing it, if I set it in the package space, but then I have no way of indicating that there was an error condition. So rather than having people check return values, they'd have to check to see whether it's like shell, right? They'd have to check whether the error condition for the last command was set to true or false or something. And that's not a good design. I mean, that's just not, because, I mean, it's not, first of all, it's not concurrent, because you only have one package variable, and if somebody else is running, then they'd be stepping all over each other. I mean, I could do a semaphore and all that, but no, that is a mess. We're not going to do that. As it stands, it just, if there's a panic, it just fails and dumps out. And there's really no way to trap that error. I mean, what I could do is I could throw another panic with a different item and then let people trap that in their own code. But that's unnecessary, since I've provided a parse and handle method which allows them to pass in their own handler rather than writing a defer. And I think that's slightly more elegant. So I don't know, both are fine. It's just a matter of how to do this. So I'm going to leave the default parse panic in here. Let's see, what do we call it? Default. I'm actually going to make this public. Default handle parse panic. So that people, this way I can document the thing. And I can say, hey, this is what's going to happen to you if you don't call parse and handle. If you just call parse, and most people are going to be fine with that. The problem with that is that actually, no, that doesn't kill the program that recovers. It just makes it annoying because it's printing out. I wonder if I can print the standard error. That's what I should be doing. Why am I not doing that? I should be doing log f. Now, what's it called? You guys remember? Anybody out in user land remember what it's called? It's in the examples all the time. So printing is a bad idea, right? Because it can't be redirected into a log or anything. So it's in the FMT package. I just have to go find it. I think it's log. It's not log f. Where are you? Log. scanf, hell no. Scanning with precision. Wait a second. I have to read about that for a second. Huh. Formatted text to yield values. Scan array from center. What? I don't think I've seen that before. That takes care of our number conversion later. We can just do scanfs on the thing instead of doing string conversions. And that's in the FMT library, which is already going to be used by most. Huh. Interesting. Has that always been there? I don't remember seeing that before. Scans format text to yield values. That is super cool. Okay. It's like the C stuff, right? That's interesting because that means that I can take those text values and convert them, like we were talking about. That that's good because that reaffirms that what I was talking about yesterday about Mac and I were kind of talking about it, making it so keeping the AST and the parse trees all string based, and then letting the end user of the AST after they parse it decide what they want to do with that. So that we don't have to deal with like different float sizes and stuff. If we hard code conversion into kind of the unmarshalling of an AST or something like that, we're making all kinds of assumptions about what devices we're on. Anyway, so yeah, that's kind of a side note. I came in here looking for, what was I looking for? Log F. Log F. Log F. F print F. F scan F. No. Or are you not stringer? Not print. Where are you? I think it might be log.print. How come I can't remember this? This is such a stupid, simple thing. I should just search for log. I think it is log.write. Yeah, it is. Different package. Okay, that makes sense. Log fatal. Log panic ln. What the heck? Followed by a call to panic. I've never used these before. Very nice. Huh. Log dot print f. Printf calls output to print to the standard logger. Arguments to header and the standard printf. So the thing about the logger that I think is important that people know, I should probably keep that up because I'm going to need it again. Is that it puts a timestamp. Yep. And so you see what it does. Boom. And that's fine. I mean, I like this, using log is going to be used in a utility, but if you have to assume how something is going to be used and it's in a package, I think it's safer to assume that it's going to be used in a daemon context and, situation. So you should use logf because this can be redirected. Also, this goes to standard output, I'm pretty sure. So I think the whole thing actually goes to standard output, if I remember right. I mean, standard error. Let's try this. Oops. To temp. Oh, I guess not. Please tell me they didn't just... God damn it. Seriously? I'm not having a good day so far. You're like, why? Because it should be... I think it's because you can set in the log, you can set what it's going to go out to. No. There we go. Voice is standard OS output with the pipeline. Yep. That's it. Oh, God. Log print line. Yes. Standard log utilities. OS pipeline. When you take a closer look at blah, OS step pipe. I don't want to use OS step pipe. Place global variables OS center with the writer. No, bullshit. Don't want to do that. Global variable OS package, yes. I'm not changing the global variable of standard out. It's totally stupid. Okay, there's so many stupid programmers out there. Can I just say, and you know what? They love to blog. Sorry, that was uncalled for. Getting started quickly with Go logging. Yeah. No, I just want a basic thing. I just want to be able to make sure that all my, that's the whole reason for using log instead of printf. I already am dubious on this particular one because they use C:\\. In order to easily code without leaving VS Code. Yep, 2 strikes. I mean, this is a good thing and a bad thing. We have a lot of console.exe. Goodbye. Let's see. Using the log package and Go. Yeah, there we go. Ah, this is from Bill Kennedy. He's a trainer from Arden Labs. Talked to him the other day, actually, on a Zoom call. He was presenting here. Init trace handler. You know what? I need to bookmark this guy. This is a good one. Open link. Now we're talking. It's old, but oh well. God damn. This is like a year before I started doing Go. Trace L date. Hey, look, you can change the date. Warning, warning, warning. I need to discard. What? What? You know, it's funny. He actually, rather than calling this, he doesn't know this probably. Rather than calling this, he could, maybe they didn't have it in 2013. He could have just made this a lowercase I and it would have called it automatically. He wouldn't even had to call it. Yep. That's a thing. Oh my God, he put his arguments on separate lines. I guess that's okay. Looks ugly though. Maybe that was Go back then. Please tell me this is writing to the right log. Oh my God. You know what? I think that they're trying to be non-machine specific. Standard out, standard error. Error handler, IO writer. Short file, info handle, warning handle, error handle. Error equals log.new, error handle. Are you kidding me? That's what you have to do? Seriously. That is way more work than I would have hoped. I'm not going to give up. I'm going to try one more. I didn't even need to go to the graphic version of that. Gelf library. Extended log format. I don't know. Just know. All right, fine. This log stuff is taking way too much of my time. So I'm not going to do it. How's about that? I'm just going to printf it. I mean, let's face it. There's not that much output from this package in the first place. So if you don't like that output, you can override the default parse panic handler. You see what I'm saying? You don't like it, make your own. Otherwise, I'm just going to printf the thing and call it a day. And I'm not even going to log printf it. I'm just going to printf it. So there. And yeah, it's because I can. You don't like it? I gave you a way to fix it. How about that? Undefined default parse panic handler. How about that? All right, there you go. Expect a 0 by 0. You know what? Because though, well, I don't know. This is the thing I always debate. Should I put the error in front of there or not? Probably not. Yeah. Because why? Because the wrapping program should be able to put the big old error thing and make colors and all that fancy shit. But it's never going to have a chance to do that because this is just going to panic and do it. So I am going to do that. Yep. I don't know if I even need to put error there. Kind of like just noise, unnecessary noise. Unnecessary noise. Get to the bottom of the problem. How about that? I mean, I could even put color on there if I wanted to. Maybe I'll do that someday. I was carving out some pegn space in the node npm tree. Yeah, I know. And because I didn't want to get taken by some lesser programmer. So that's a joke. And I was out there and I was like, oh God, because I was doing NPM and I was like, look, all the emojis that come out when you use the tool and all the pretty colors and everything. I was like, okay, I'm done here. Anyway, I mean, I like shots fired. And so, yeah. The biggest thing I hate about NPM is all the people, including me in an earlier time, who camp on package names and don't put anything in them. They do it all the time. Yeah, it's all like this anticipated package you're going to make someday. It's like so bad. Also, the second biggest thing I hate about that, besides there's obviously more significant things to not like, but is you can't ever take something off. Ever. I actually wrote to the support team and I said, I created a scaffold for a library that I was going to make that I found that I don't need. I have another one. And I want to delete it. And they said, no, we can't do it. I said, it has no code in it. I said, still, we don't care. You can't delete it. It may be used by somebody. I said, it's not being used by anyone. I promise you. Nobody's using it. It doesn't work. Because still, we're going to keep it. You know why? Because they wanted that sweet, sweet number to go up. NPM even had an official policy. NPM had an official policy to make small packages instead of big. More smaller packages. And I don't believe it was completely based on good architecture. I think the reason they did that is they wanted to inflate their big billions of number of packages on the system. If you could actually evaluate how many of those packages actually are doing anything, I bet the number would be at least 75% lower. Yep. But they did that, and you know why they did that? Greed. Because Mr. Isaac Schuler wanted to start the NPM thing and all the other stuff that went with it and sell it off and make his money and then bail, which is exactly what he did. I love that Ryan Dahl throws him under the bus at a Node conference. Says, well, I thought it was a good idea. It actually was a horrible idea. I should have paid more attention. I shouldn't have let it in there. And 10 things I hate about Node from Ryan Dahl, the creator of Node. Go watch it. It's hilarious. It made me forever a Ryan Dahl fan. Because he just owned his mistakes, and other people don't. They just want to make money. Like Isaac. Sorry, not an Isaac fan at all. I'm not an NPM fan at all. GitHub bails them out, which meant Microsoft bailed them out because they totally fucked that whole organization up when they made it. Talk about a disastrously bad Silicon Valley story. The whole NPM story, and slightly joint as a part of that, but not really. That was kind of like collateral damage. The whole NPM story is one of the worst disasters in all of tech history. I mean, starting with like the internal fights at the executive level, their whole code of conduct shit, the io.js like fork, over a code of conduct over nothing technically broke their consumers' code bases essentially, and leaving them hanging, not knowing what to use over a fucking code of conduct because they said we're going to take our donuts and go home, or our ball, or whatever. And then what? And then they had massive people leave their organization and write huge scathing exposés. Go read them. It's amazing. And this was all before all of the worm shit and the Lodash crap and everything that they just disintegrated into nothingness. But they have their happy little colors. It is such a catastrophic failure. I mean, the whole entire Node thing, from the beginning of Ryan Dahl abandoning the project and TJ Holoraychuk, who made Express, to this moment where GitHub, who had to be bailed out by Microsoft because it was a disaster and it was failure and it was dying and it was not making money and it was about to get all this code was going to just kind of go away, and all of this scandals at the top of the chain in GitHub. And so Microsoft swoops in and saves GitHub, and then GitHub swoops in and saves NPM. Meanwhile, everybody's sitting back on the sidelines going, huh. If you're an architect, if you're a CTO who gives a shit about your company, you do not want to use anything from those organizations, at least from NPM. And if you do, you are taking your life in your own hands. They had to make Yarn because they had to make up for all this. Facebook had to make Yarn to make up for all the shitty things that were in the original package modules in Node originally. There's your shots fired with objective backing. Go read it all. Dude, I swear to God, if you look, I use Node, obviously. It's the only thing Node is good for is like JavaScript on the server side, like building and stuff. And you have to have that for that. And, for some reason, people decided to put stuff in React, and TypeScript had to come in and make up for that's a JavaScript thing. That's not so much a Node thing. It's so bad. All right. I need to take a break and go back to work. I had to just take a moment to just laugh about that because it's just so bad. It's just so totally bad. All you have to do is compare that to, projects with, this is one of the reasons Go is so amazing, is because they considered all of these things. They considered how are we going to package this. They said, no, we're not going to even have a package system. We'll have a package system, but we won't have a registry. There won't be a registry. We'll have a module cache so we can help people out, but we're not going to have a registry. We're going to use the existing systems for that. Those are one of the most brilliant decisions in all of tech history. And there's already an entire system, and now GitHub's trying to do it for NPM and for everything else. It's like build packaging into the system, build it based on Git repos. We'll actually look at the version numbers. And that was a pretty big gamble. Think about that. What if Git hadn't gone anywhere? But they're like, no, Git's not going anywhere. And not only that, they based it on GitHub and GitLab's service offering, because I do not believe looking up tags and version numbers is built into Git itself through the URLs, and that's what they had to do. So Go is fundamentally dependent on how GitHub set up its first thing. So there's lots of reasons to give GitHub credit. Obviously, I'm not slamming them as much as I am Node, but I just think it's funny. All right, enough of that. So the panic handler. So the problem with the panic handler is that when something panics, there's no returning from it. There's no trapping it and continuing your way, and there's no, true exception handling where you put a try around the thing and then just continue your execution within the same function. You panic or not, right? And the only way you can trap a panic, the automatic way anyway to trap a panic is to defer and to put your trap in there, and then to pull that down and put it in here. So yeah, let's go ahead and do that. So what do we got? We got the 0 at 0 byte, which is what we want. So our test is working actually. So that makes me happy. And we don't need to really log anything. This is going to be hard to test because there's nothing to check. And Actually, this is an interesting case where an example test that makes more sense. Can I say this? I run into this the other day too, and I was not. This is a better fix. So you can do parse, right? And we'll just parse octal. And actually, an example test is better for this. Because why? Because I can actually, because it uses reflection and it looks at its own output, I can do this. I can do expected 0 at byte 0. Expected is O at byte 0. And so then I can do this. I can do root octal. And I can use example format tests. They won't show up in the documentation because they're not being used against things that are public. But sometimes you actually it's still nice to have it. Because obviously this one I can't do this. So it says here pegn declared but not used, PEGX declared. Okay, so I don't even need that. Wow, look at that. Are you kidding me? I can just do that. Holy cow. So that little test I did right there could not be done as easily. I would have had to do all kinds of like IO redirection and stuff in order to capture the output. Meanwhile, I can just do example parse octal, expect 0 at byte 0, and I can test my octal. So let's do a bad test, shall we? Let's do a bad test. So let's say this is a good, oh wait, let's make this one a good one. Octal, redeclared this block. Well, yeah, I'm sorry about that. Let's do octal bad. I wanted 0 at byte 0. Okay, this guy didn't get anything. So let's say, well, actually, before I forget, we need to go into our pegn and remove all the error returns because they're lying to you. There is no error returning happening. So it simplifies the signatures but complicates the trapping and stuff with panic. So let's go get this out here. And so I'm going to delete all this. Expert expression nil. So I think that's all good. Down here, truth is we're not going to be, you know what? No, I'm going to have to put a trap. Oh boy. This stuff's going to get hairy because after trapping that panic doesn't mean I can recover a thread of execution. I might have to do some embedding to get to transfers. I mean, I can do it, but it's going to be trickier than I wanted to. Damn it. Because why? Well, so much for the must stuff. I had like must validate and all that stuff. I don't know. I mean, this is one of those cases. There's this constant design decision that's tough to make about whether you should leave a panic in place or you should return an error. I think the community in general thinks that you should be returning error when you can and not panicking. I think that's a pretty safe statement. You know, the people using this tool are going to be, I don't care how easy it makes your private, definition parsing to use a panic. If you're going to panic my code, you got to tell me about it. And there's a lot of stuff in the standard library that panics, and stuff that doesn't panic, returns an error. And usually when they have something that panics, they add the word must to it. So they would say something like this, must parse. And if they have must parse, that means it'll panic if it doesn't parse. And it makes their code a lot simpler. But at the cost of having to put a defer someplace, unless they don't care about the defer. I do, Jan, but my environment right now is pretty messy. Because I just moved in, so I'm like, every night I've been taking a little stab at putting away my clothes and tech and stuff. So here we go. We have Default parse panic handler. I think this is fine because we gave him a handler. You know what I mean? For that panic. But it can't recover execution. So you'd have to get pretty complicated how to do that. I'm trying to head off the pass some stuff that might creep in later. Parse 03, parse string 03. See, this is how it would be used, right? Well, this is more of a must parse string 3. So I can't leave this topic for right now. I'm kind of hung up on this. I really think that I should be capturing an error here. I just do. Should be arguments to return. Pegn line 34. I do. I feel like I should be handling a return there. And I'm not sure how to do that. Because this function does not get taken over. It's not like it gets it's not like it replaces the current running function with return values. It just gets called as if it was a separate function, period, independent of everything else. I think underneath it's a long jump. I think that's what it's called. Same for like setting alarms in Unix and stuff, and having them have handlers trap those events. So the problem is that there is no way to return from this the way I'm doing this. So even though it's really clean and it works really nicely, I don't know. I have to give some more thought to that. I'm really hung up on this right now. I just am. Because this means that match and match reader, all these are going to be panicked as well. And yeah. The thing about panic is that it kind of forces you to let the caller make the decision about what to do, because they're the only ones who have all of the scope and state that are needed to handle recovering from a panic the way they want to. And this is my attempt to give them that, but I don't even think that's actually a good idea. I think it's probably better to force them to trap the panic than to say, hey, I have a default handler. Because if I get in the habit of doing this, I don't know. I'm pretending I'm an end user right now. So if I was going to use this package and I just wanted to have a real-time parsing of a PEGX thing, what would I get? And I'm going to see if I'm missing something. Maybe there's a best practice that I'm missing. I mean, I use panic, but not a lot. It's not like, because I try to avoid it. Yeah, there's an example for this. Defer, handle out of bounds. Panic out of bounds, slice, return. Bye, Gaming Weasel. Handle out of bounds. Recover from panic. Handle out of bounds. Recover from panic R. No, that is not it. No, that is not it. Since get and check creates panics when it is recovered, therefore the return value will be the default value of its type. Wait a second. Defer, handle out of bounds. Defer, handle out of bounds. Handle out of bounds. Recover if R is not equal nil. If recovering panic, right? Okay, and what? Out of bound access for slice. What? Oh, so they're doing something in the caller state, and they're doing an embed. Yeah, that's stupid. I don't like that at all. That's like check and get 8-2. Panic out of for. Wait, am I missing something here? Is it actually proceeding on? It shouldn't be. I should be jumping over here, doing this, but then it never gets the return. No, this is not what we want. No. Creates a panic, which is recovery for the function. Return value of check and get will be the default value of its types. Wait, I have to read that again. In the burn program, we have check and get function, which gets the value at a particular index in the slice. Yes, okay, fine. If the index passed to the function is greater than the length of the slice, then it raises the panic. Duh. This is also a handle out of bounds function. Recover from the panic, so we pass index 2 to check and get function, and it raises the panic, which is recovered in the handle out of bounds function. That is why we first get the output. So what they're suggesting is something that I might have missed about panic, and they're suggesting that it actually returns and keeps going. And I'm going to test that just informally right now. So what they're suggesting is that yeah, it should be there. God, I am an expression. Yeah, and that's fine. So yeah, let's try something else though. Let's try interesting. Okay, so that did what we thought. That recovered from the error and kept going. Let's actually test that down in this one. Let's do pegx.ast. I don't think we can get to the AST actually. Oh, I can though. I can cheat because I have internal knowledge of it. There we go. Yeah, that's, whoa, that's definitely an error. That's definitely an error. But whatever. That should have been a lot more than that, actually. So I've got to figure this out. But I know it can be done. It's not so I'm not as worried. Anyway, this guy down here is the one I really want to work on. So yeah, let's do this. Let's say parse string and then what? PEGX. It should be nil, actually. Fatal, yep. Octal bad invalid memory address. Invalid memory address or nil pointer reference because there is no AST. It's nil. This will just be I am an expression. Bad expected 0 by nil. What? Oh, right. PEGX is nil. Parse string 3, PEGX. The interesting thing here is that it didn't write, it did write the error, but it kept going. So that means that the panic recovered and it kept going. Okay, that's what it's supposed to do. So yeah. A different problem here though. So what we really want to have happen is we want to recover from the error and return it. And there's no way to know what that error is because we can't derive it from the handler. There is a way around this though, and that would be to, how's it going, gluten-free message? So a way to do this, if we put the defer in here, we can actually do this. Okay, so I feel better now. In fact, I'm gonna try this a little bit differently. I need to take a quick break. When I come back, what we're gonna do is we're gonna put the defer, and we're gonna make the defer a closure, and we're gonna put the closure inside of the function so that it doesn't have to use package scope, and we're gonna give it the error reference so that we can return the error reference after the thing finishes, because it just looks like we confirm that when you recover from a thing, it actually picks up on the line after that, after the panic. So it resumes and without throwing, which is good. If that's true, then that means if any one of these things has an error, we still have time to catch it and do our return. So we can try catch the exception, considering panic more like an exception. So I'll be right back in a bit to do that. I'm going to leave this on, and I'm going to go mute though, because I tend to be loud when I talk. So yeah. Wait, where are you? Where are you, OBS? I know you're there somewhere. Show. Why are you not showing? Oh, there you are. All right, I'll be back in a bit. All right, I'm back. I'm back. Nice fishies. Happy fishies. All right, so we need to do this. I got my coffee, though. Good lunch. Let's see here. We've got... yeah, we're going to get rid of this handler here, and I'm going to try something different. Since parse and handle is the one that's getting diverted to... all this stuff actually needs to be rethought, and maybe have a must put in here somewhere. Whenever something like that happens to me, I end up just killing stuff temporarily. So I'm going to do that. I'm going to get rid of this. And I'm going to try a different approach to the recovery from the panic, which will allow me to return an error, which is really bothering me. That's what's causing all of this. It really bothers me that the consumer of my package is going to have to deal with panics. I don't want to force people to do that. I'd rather give them error conditions to deal with. It's not nice to force people to deal with your panics. It's more idiomatic Go to create a function equivalent to the other one called must that actually does a panic, so you can let the user choose of your package choose, hey, I want a panic here. I'm good with that. It's just not polite to force people to trap your panics. I've had to do that up to this point, so I'm okay with it. If it comes to it, I'll leave it there, but I want to exhaust all the possibilities of being able to return an error function and recover from the panic. The difficulty arises in the fact that it changes scope and everything when I do it like this, right? So this is actually a bad idea. I'm going to need that code, so I'm going to keep that around, but I'll remember it. It's not that hard. But it becomes an issue because why? Because and this is stuff for me to kind of summarize quickly for those who might be beginning out there. And by the way, this is when closures are essential. People ask all the time, well, why do I need a closure? What's it good for? This is a really, really good use case for a closure. And what a closure is it's a function that has been defined within a scope that has variables and stuff outside of it. And then that stuff gets enclosed within it after it's been defined and assigned. And why is that important? Because then it can operate on things that are not necessarily in a global package scope, because they get enclosed, they get embedded inside of the function in every call from that point on. So it's like a pseudo global variable without using globals. It's really, really critical to functional programming. So what does that mean? That means that having that extra function out there is a problem, because it's not enclosed. The only thing enclosing that thing is the package itself. So in order for me to communicate things like error messages and stuff, because when you panic, you just runs that function. It doesn't pass anything to it. It just runs it. So the only way to communicate with that function is to put stuff in the global package space, or to create a channel to some weird shit, like that. Or to put it in the panic itself, right? So you can put it in the panic interface. The thing that gets recovered from the panic can contain ways to communicate, so that it can communicate with the caller and stuff. But all of that, I think, can be addressed by using a closure. And so we're going to try that now. Basically, what we're doing, we're going to take this exact same those lines of code. And rather than deferring, and here's where it's going to get interesting. Rather than deferring a handle like this, we're going to make an anonymous function that gets executed. Now, the problem with putting it here is that I can't enclose anything into it. So yeah. So what we're going to first have to do is we're going to do this. We're going to say var error. All right. But now I'm going to enclose this error inside of my function. So to do a proper panic recovery, got to remember that defer runs no matter what when the function ends. So it's used for other things besides panic recovery. It's used for, handling, closing out resources and stuff like that. So the first thing we need to do is check if we're dealing with a panic recovery. And the way to do that is to call recover. Recover is a useless keyword anywhere else but within a defer panic function. And we have to check if we have a P. So if P equals nil, if P does not equal nil, then we do stuff. Otherwise, we don't care because we don't want the defer to. The defer runs every single time this thing returns, which is, by the way, something to consider, because if you're trying to write a super fast parser, you might not want to put a defer anywhere in there because it's going to run that function every time. That's an unnecessary function call every time this function is called, no matter what. So this is the kind of thing you don't want to mess around with at the top level. It's also why panics are really bad for performance, if that's your primary concern. So don't do that. So anyway, undefined parse string. We don't need that. Am I calling parse string? Probably am. Actually, fine. Parse string is fine. So I'm going to return PEGX, and we'll return an error as well. I swear to God, we're going to make errors work. I don't know. I can put you over here. Mismatch one variable returns 2. Right, X and nil. Actually, we'll do error. So error is nil by default. That's a 0 value. And so yeah, let's change this guy back to returning an error. And we got our defer here. Make it nice and pretty, I guess. I don't know. Should we make it pretty? Nah, whatever. I don't care. Our signatures aren't lined up. I got to fix that. Pegn expression. So we are, where are we? Still off someplace. Oh, the defs test. That's fine. That's the testing thing. We're gonna fix that. All right. So this time, what we're gonna do is we're gonna embed this error, and we're gonna say that the error equals P, and that means that if we get down to these lines here, we should still have the error. Missing error method. Interface does not implement. Missing the error method. Okay, so I'm probably going to have to cast this. And that's somewhat bad to do. I would only do this if I knew exactly what I'm recovering from. All right, so back to our defs test. So yeah, we're gonna. I mean, that one I think was working. That one needs to change. So that test needs to change. We need to. Yeah. Well, I need to implement a better print and stringer on PEGX, on the expression class, struct, whatever. One variable plus parse string returns 2 variables. Where are we talking here? Oh, right. I'm going to need to do something with it, of course. I mean, just for now, just do whatever I can. It doesn't matter. Oh boy. There we go. Here we go. I assume that's coming in this guy here. I'm gonna turn him off for a bit. All right, so no errors here. It actually parsed it just like we would expect. Good. No. And that's all good. Why are you not happy? Oh, 03, yeah. We do have a bug in the Octal Parser. I'm going to go ahead and fix that right now. So, no, I'm not. I'm going to stick with this error condition thing. So this one's got an error. I'm kind of wondering why this trap didn't work. Oh, because we're parsing string. No, that should be fine too. So, I'm going to allow for that to run again. I don't know where that's coming from. It's a little bit too long of a trace. There we go. Panic 0 byte recovered. Panic interface conversion. Pegn expected is not error. Missing method error. Oh, it's not an error. Okay, that's fine. So this is a panic after a panic, which is fine. All this panicking. But that's expected. The reason for that's because I can't cast it to an error because I don't know what it is. I probably need a type switch here, and I don't. I'm just gonna cheat here. Eventually, I'm gonna put a type switch here. So we'll go ahead and do that. Type switching, by the way, the only way I ever considered doing type switching is this way. You don't have to do the V equals, but the V is actually the casted type. So that's where you want the casting to go on, and I always use V for that. So yeah, and then the default type, I'm just going to go ahead and FMT the thing and tell people what it is. Just for now, I mean, I don't care. And then a capital T is the type. This is a printf. What am I talking about? All right, so this is a printf. And both of these will be V's, VV. And that should give us what it is. I'm going to put let's see, 0 at byte 0, pegn expected. Interesting. So that's interesting. Let's do a Q here. Yeah, there we go. All right, so we got a pegn expected value. I totally forgot about making those structs, but that's good. And the expected 0 by 0 was actually a stringer interface, so that's why that's not working. So actually, we can do this now. We can do case. This is just a great way when you're dealing with types you don't know what you're dealing with. You can just kind of get the type and print out the type at first, and then kind of filter out all the types that need to be supported. In this case, I'm going to have a pointer to a pegn expected, which doesn't need a prefix because we're not testing in that way. Yeah. So yeah. 1 to 0. So if we have that, we can just print. I mean, God, we could. I can actually just grab the panic item. I don't know what to call it. Oh, interface. What do we call it? We'll call it a panic. It's like the argument, right? Panic error. I don't know. I'm just having fun. So if that's true, I mean, that switch is like way overkill, right? But I just want to do that for now. So we can say P error equals P. We can just grab the panic. Oh my God. You know what I could even do? Can I really do this? Holy shit. It cannot possibly be that easy. I think it can. Oh my God. Oh my God. And how do we make an error out of this? So yeah, I'd have to compose an error out of expected. And just trying to think. This is kind of part of my whole error handling thing. I got to give some more thought to. I mean, I can probably use that W thing, but the problem is it's the expected thing is not an error type; it's a struct. So I actually think I can do that. I think I can. Yep, undefined FMT. What? F. Use the P interface as type string and argument to error F as type assertion. Fine. I will do this then. How about that? You're gonna let me do this? Yes, you are, because you're nice. You're a nice little error, aren't you? So here we go. There's our enclosure. Our enclosure is actually the panic recovery thing, and I can even do this. And when it will let me do that? Oh my God! I think I just found a new idiom. What is an idiom? For those of you who've been watching for a while, I use this word a lot. What is an idiom? An idiom in programming. I like to throw shit out there every once in a while to help people out. A programming idiom or code idiom is expressing a special feature of a recurring construct in one or more programming languages. Developers recognize programming idioms by associating and giving meaning to one or more code fragments. An idiom can be seen as a concept underlying a pattern in code, which is represented in implementation by contiguous or scattered code fragments. What a horrible definition, Wikipedia. That's exactly what I would expect. Anybody want to know why I'm trying to make my own knowledge base that actually talks English to regular people? This is why. You don't have a consistent target readership of Wikipedia, so people write for whoever the fuck they want. And all an idiom really is something that is a practical pattern that is reused, that makes sense to people, and is an easy way of expressing something, even though it hasn't been specified. So it's not like syntax, which is specified. It's a sort of a pattern of how to do something. So here we go. An idiom in non-programming language is a saying or expression that is unique to a particular language. And that's like in English or Russian. I study Russian, повторение матучения, I think that's more than just idiom and idiom. I don't think that idiom is even the proper name for that, but that's a saying that means, repetitions of other learning. That's more of a saying than an idiom. So yeah, generally something which doesn't follow the rules of the language and just exists because native speakers just know what it means. I wonder, that's more of a saying. So that's a pagaborka, which is like a little saying. So, but an idiom in programming, Python is a strongly idiomatic language. There is generally a single optimal way of doing something. And that's what a programming idiom is. There's like one sort of best way to do something. Let me give you an example of an idiom in Go. In Go, it's a very common idiom to never use the else keyword. You can just use if, and then you have like, blue sky kind of top down logic. And so if something doesn't fit that logic, then you if yourself out of the thread there. Literally writing else statements. Yeah, it kind of is. I know, doesn't that sound funny? It's you just have to ask yourself, do I need an else? And there are definitely cases where you do need one, but that's an idiom. So I think when I said earlier, I think I just uncovered an idiom here. And this idiom or recipe or whatever you want to call it is that when you actually want to trap a panic and return it as a nice error, you need to use a closure inside of the same function. And the reason that's an idiom is because that saves you from using the package space and a bunch of other things. So there you go. There's my idiom for today. And I'm super happy that that actually works. I think the thing I was missing in my panic knowledge earlier was that when you trap or when you defer this, it does the long jump over to run the function, but then it continues execution. So that is something I was missing. So it recovers and then it sends control back to the caller. And I was thinking it was more like a set alarm long jump in Perl or Python or any systems programming where you can't return control back to the caller. But today I've been reminded that recover actually does return control to the calling function. So there was a panic. A panic happened on line 21 here, and then this recovered it, set this local variable within the parse function to the panic's thing, in this case an expected struct, and then it returned execution to the next line so that I could go ahead and return it as an error. So I was able to trap the output of the panic by using this closure here, and then return it. And I missed that. I probably knew that at one point, but I had forgotten that return control to the caller was a thing that panic does. The defer trap, p recover is actually sending back control to the caller, which is really great because that means that you can use defer. If you know about exceptions from other languages, you can use panic and defer as a pseudo exception syntax, which is another reason that I think it's just absolutely brain dead stupid that people keep proposing exceptions to Go, and everyone gets thrown out. There's been like 2 proposals so far, and I want them to keep getting thrown out because this is fine. I don't want to have exceptions and defer and panic, because then it would be, then it's going to start looking like the kitchen sink, like Rust or something. And I don't want too many options. Awesome. Honestly, I don't. It just keeps the language simpler. It's easier to recover. Understand everything. All right, so this is actually really good news. This means that I can rewrite those other things the way I wanted to. It also means that I can do the very idiomatic, this is another idiom, the idiom, best practice, pattern, whatever you want to call it. But rather than saying parse, what they would do is this. Okay, so I'm going to go ahead and do one right now since we're talking about it. It's very idiomatic Go to say this, to say must parse. All right. So if you don't want to have to to deal with that error, right? And the reason that people do must parse like this is so they can use the fluent pattern. I understand it's called. It's the one where you use dots at the end. You do a whole bunch of trailing dots, right? Well, you can't use fluent pattern if you've got a 2-value return, which is very, very idiomatic Go. So if you delete this off, now you're good. Right? So now you can do some funky, fluent stuff. So you can do must parse, blah, and then dot, and then add a dot. You can have like a whole chain of things you do. But you do that at the cost of invoking a panic. So if you do that, then guess what? Bye-bye, panic. Now I just let the thing panic. And so, yeah, if you do a must parse, I actually can probably encapsulate one of these functions with the other one here. Just give me a second here. So yeah, I'm pretty sure I could. So this is just going to return the expression, right? So this is very, very idiomatic. People will add a version of a thing that panics, and they'll have a version that doesn't, and they'll put must in front. So must parse. This is actually in our thing already, because this is how regular expressions, there's a must compile. If regular expressions are annoying enough, oh hey, it's already down here, right here. So match string, check, validate, length. Let me see if I can find it. It's in our, I think it's the XPR. Yeah. So here you go. Compile, must compile. So this is a pattern from the regex library for the standard Go library. This is what they do. And so yeah, that's a thing. And that's the reasons for it is that they, you're able to use the different patterns if you want. Anyway, so where is our test here? We got our tests going on. Let me go back to what I was doing before. What was it? Defs? No. Is it defs? No. Why am I so lost? pegn.go, yeah. All right. So parse and must parse. I actually can call must parse here and do the same thing. I think. Yeah, I can. So I can do this. I can say return huh. I wonder if I can put it right here. Man, that would be so cool. Yeah, it must parse PEGX. Because it only returns an error, right? And then the panic will only happen if it does the thing. I wonder, I think it might have to be on its own line. No, that worked. That worked. Oh my God. It's like so cool. I probably should look at the underlying must compile implementation for regex. That'd be probably good. Some good patterns in there. All right. This reminds me I need to come back to this error. This is actually a scanning error. It's a different error. And I can come back to that after the next bout of coffee. But I've got my entry point here. So we got nil, one expected byte. I don't think it's I don't think. Wait a second here. Did I get that right? Let me go check my tests. Wait. Oh wait, I was testing it. That's what's confusing me is that some of these tests are in the def tests, but I'm still using parse. Oh right, and I'm using parse string instead of must parse. So that one is definitely off. This one should work though. Won't expect it back. Nope, that should be fine. So this should be a nil. No. This should have got an error for sure. Why did this not print an error? Oh, no. That's a valid octal, right? So, oh, no, because there's no O. That's right. Expected O byte 0. That should be the error. So something's going on wrong with my panic. That little thing I did. It messed something up. So let's see if we can fix that. I was afraid I might have to do I don't think you can put it in the same line. I think it has to be 2 separate lines. So let's do that. Let's do PEGX. No. Let's do was it AST or EXP equals must parse PEGX. I mean, there is definitely some indirection going on here, but I don't know if that matters. Still the same problem. Well, that means this can stay there. Got some other error to find here. All right, so what? What is my missing in my error? Parse string. Do I have must parse and parse string, and I have must parse string? Parse should be good. I should have must parse string too, though, to get them all done. This is getting a little more time for me because this is the main user interface to the package, and so I really want it to be clean. If you know what I mean. Must parse string. Must parse. All right. And we do have an error here somehow. I don't know how. Gotta go find that though. So it should not be parsing that octal. So let's go back to that. Parse string should give me an error. It should be giving me this specific error and a nil. So here's octal. PEGX parse string 3 should be a nil and an expected 0 at byte 0. So we have an error there. Maybe the error is not being returned properly. I want to see if it's even making it in here. Yep. All right. And let's actually see. I'm gonna cheat here. We're gonna do the. I just want to print out the panic really quick. Okay, so that time it did get it, but it's not being set in P here. So that definitely got it, didn't it? Let's see. Yep. Yep, that got it. Okay, so it's definitely recovering from the panic the way it's supposed to. And that's all good, so we can delete that. But it's not making it down here. I mean, somehow the enclosure is not working. I might have to make it a pointer to an interface. Yeah, I do. I think I need to make it a pointer. I do. I think that's what's going on. I bet you anything. Yep. So, because I went to choose an interface instead. I'm almost positive that's what it is, but here's how we'll know. I shouldn't have deleted the other one. Yep, just another nil, right? So that's definitely a problem from a pointer. So we're going to say that this is a pointer to an interface. And that's going to be interesting. Because this is being lost in transit. I could have swore we just fixed that. Let me just, it is definitely making it to this line after the recovery. That was the thing I was worried about. That's the thing I tested earlier. So that's not the issue. So the issue is the values not being saved. That means it's if it's enclosing it, it's enclosing it and returning a different value, which makes me think that it's not an actual value. Cannot take address of recover. Fuck. That's not good. Well, we know we did it without doing the thing. I mean, you guys can see the error right there, right? So it's not printing it. It's printing a nil again. But if I put that exact same code inside of the function, it has no problem with it because it recovers it just fine. See that? So there's something being lost between the time the function call gets called. Oh, duh. Oh my God, I'm so stupid. Do you see what my problem is? Obviously. I'm trying to check. Okay, so it definitely is order of operations because look, I'm trying to check for a P that's not getting tracked because this defer is not getting called until must parse gets called, which isn't called until the return statement. I feel stupid. Oh well. But that's the thing with defers. That's not particularly, intuitive what's going on. So we want to must parse up there, right? And we actually do need to capture the expression and return it down here. And this will take care of our problem probably. So this should then print the right thing, but it's not. It's still not printing it properly. And that's a little disturbing because, oh no, wait, no, No, it's not. It's still not doing it. So let's think about that for a second. This one is printing just fine. Hi, Mark. And this is a... So here we see the in-defer is running, but the other one is not. Running down over here. I read it. So this whole defer stuff is hard enough to get your head around. So hopefully this does help some people figure this out. It's particularly if you're coming from Python or Java, where you've done a lot of exception trapping. And so here we've got a defer on going on over here. And frankly, this is one of the reasons I don't use panic and defer as a very much. It turns out I really need to use it in this particular case, but I tend to shy away from it and stay very functional. This is one of the, so that's why I'm not as good as it should be. So here we have a printf, and it's trying to print the P. Well, the P is up here, should be enclosed here. The only conclusion I can make is that the P is not a pointer, and so it's assigning to something that is different. And I might have to defer the... I mean, we had this working earlier, so I know I can get it working, but it was with the switch type. So I might have to do another variable assignment after we do the P recovery, just to get the I suppose the reference to stay. Right now, it appears that the item that's getting returned, the symbol that's getting returned into P, is actually going away when it leaves the scope of the defer function, even though it shouldn't, because it's supposed to be an enclosure. It could be that assigning it to a new variable, which does exist out here. This should not be any different, but that should work, right? And then we do something like this, another equals P, which should not work. That should not be a thing. And then what? So down here, we could just do another. That should be nil as well. That should not be anything. Yep. So that because it's just another symbol assignment. That should not be anything. Yeah, because we need it in this particular scope. I'm kind of annoyed with this because I thought I just did this, and now it's not there. So what do we got? We have, well, this part was kind of dumb. This part right here. So must parse is being called. And so when must parse calls, it's coming down here and it's blowing up. You know what? I wonder if that's it. You know what? When it was working before, all of this code was in the same function. So I wonder if it's losing the P thing when must parse gets called, because must parse comes down here, it blows up in here. There's no defer in here, and therefore P doesn't get saved as an enclosure, and then it comes back and it doesn't have any idea what P is. Holy shit, that's it, people. That's exactly what's happening, which means that this like nice encapsulation of the other function is not going to work. So I bet you anything, watch this. So I'm going to do a scanner here, and we're going to get rid of this must parse call, and we're going to use all of the line items that would be done in the other one. And I bet you, nope, still nothing. Oh wait, no, wait, there we go. Got, no, wait, and defer. Arg. We still have a problem, people. It's not working. Even with that. Well, now I'm really confused because that should definitely have worked. So x equals new expression. You bet is everything you have. You bet us everything. I bet you everything. Yeah. Now you win. You get everything. I mean, that should have fixed it. I mean, let's be real here. So S, there is nothing in the way here. No, wait, now, no, because the whole idea of panics is that they propagate up, right? So yeah. After parse P, this isn't in the way here, people. Could be my error message itself. It's not even, oh my God. Please, please, no. Oh, wait. Wait. Oh my God, please, no. Please, no. If this, there's, right now I'm considering the possibility that my first experiment with this whole thing about the long jump not returning and returning magic call of caller, control to the call stack, that's what it's looking like is happening. And now I'm a little bit scared, because that means I won't be able to use panic to get error return values. I'm not ready to say that yet, but the first thing that I said at the beginning of this last segment is could potentially be false, because look, this line is never getting executed. It's not. It's never getting here. And the only reason that that would happen is if the defer is not happening. Yeah, that's what's happening. And the only reason that would happen is because this guy's panicking. And when this panics, it doesn't recover. It recovers, but it jumps away and it never hits these last two. And that would be why we're getting 0-0 for the return values, because there's nothing being returned at all. It's never hitting this line. And that is bad. And I hope that's because I have a defer inside of the root.parse someplace that's causing that to happen. Because if not, I've just confirmed that I can't use panics for this to recover and send a proper error. And I really don't want that to be true. I need more coffee. All right. What are we talking about here? You have everything. You get everything. I was wrong. Well, if you're watching this, then you're learning along with me on some of these quirks about panic and defer. I'm just gonna own it. I don't use panic and defer very much because of these problems. It's easier to deal with channels than it is to deal with panic and defer. Unless you're doing really simple stuff like closing your file handle and that kind of shit. But when you're recovering from panics, it's really important that we understand this. And throw a warning if a line can never be reached, etc. Yeah. See, well, this is the thing. There's probably some vetting I can do here that would show that. Let's try it, actually. Refers to known field. That's fine. Refers to unknown field. Unreachable code on JSON line 366. We know about that. So you can get unreachable code samples in GoVet. But it should have given me one here, right? And it didn't, which means, I mean, that's a good sign. That's a good sign. If GoVet is doing what it's supposed to, that should be, and by the way, I'm using the macro vet. So, yeah, you can look at my MRC if you want. So, for all the Vim setup on the Golang. You want some of that stuff. But that would suggest that Go thinks that this line is going to be hit, which makes sense because this return here is if this return wasn't happening, then that would be an error. Yeah, macro vet. Do you know what I'm talking about? There's like a big vet. It is. There's like all kinds of editors. There's Go vet, but then there's another one here. Let me talk about it for a second. So, where is it? Oh, metalinter. Sorry, there's no such thing as macro vet. I got the name wrong. Metalinter is the one I'm talking about, and it's big. It has Go vet built into it, a bunch of other stuff. Go vet's actually really nice. It doesn't check for race conditions or anything, but it does check for other stuff. So again, back to the problem. This line is not ever getting reached because why? Because this guy is panicking, and so the panic hands off control up here. It gets recovered, and then it prints in defer, which is what we get over here, and that's it. Then it's done. And I'm thinking it jumps to exec, return x f format down here because x is nil, but it's the problem. Wait. No. This should, if this returns, this should not be nil because this was assigned up here. You see what I'm saying? So this is telling me that return line is not getting hit. So there might be something wrong with the test again. Let's go look and make sure. So yeah, so that should be, so nothing gets returned at all to PEGX and nothing gets returned to the error. Those two things are both 0. And so this test is proper. This is a good test. It's just not doing what it needs to do. So I think it's time for me to look inside of the parse def itself. So defs.octal. So this is what it does. It marks the current, it scans the rune for 0, and it fails. Scan rune fails, and that throws an error. And scan rune is in the scanner. Yeah, so we can look at the scanner. So scan rune decodes it. That doesn't get it, doesn't match. That one actually does match fine. That's not a problem. So this is where that one doesn't match. So this is where it gets the error, and that's where the expected error comes from. So it panics with the expected error and never advances the cursor position. So in the data thing. So this is doing what it's supposed to do. The problem is I don't think it's getting here. I'm going to try something here. I know I got to remove these later. I know this is lame debugging, but so it's actually making it there. You see that? It's making there, and it's throwing the expected error. Well, we already know that because of this, because the in defer thing, right? So that's not really any new information. We already got that part. Because why? Because it's getting, whoops, wrong one. It's getting to here. So it's actually recovering. It's throwing the error. It's panicking. And then it's getting to this line. Yes, I made it. It's getting there. And wait, do I have another made in there somewhere? Please tell me I don't. Shit. This is what happens when you use print to debug. Actually, the really great thing about this, let me show you, this is a great thing about Go. If you use print instead of print FMT print, you can grab out all of your debug statements from everything pretty easily. If you use -I. How do I make it sensitive again? Okay, wait. There we go. And yeah, if you have to, you can go find all of your print statements that are left out in there. Which I don't see. I don't see where it's at. That must be an old one. Yeah, it's interesting. It's not even there. I wonder what that is. Anyway, so nope. I need you. Yes, you. All right. So yeah. Oh, here it is right here. Yeah, get rid of that. So it's not making it. It's the obviously the one that works makes it to both places because there's nothing. But this is not happening. This happens and then it's done. And that means that any control of the parse function, which is how I initially understood pegn to work. And that's why I was checking this. And I thought I had been schooled on how they worked earlier, about 10 minutes, 15 minutes back. And it turns out that the way I understood it to work seems to be how it actually is working. So this is going to require a little bit more Go research on my part to get really solid on how pegn and defer work. Because what's happening is, as soon as this panics, none of this stuff gets returned. What I want to know is, what if I return? Well, no, we're doing that. This X should not be nil. Check this right here. That should not be nil. Why? Because it's defined right here, even before it runs it. Which means, strange as it sounds, the panic that's being caused in this line is forcing this to return with nil values, even though there have been values assigned. So this isn't like it's jumping down to this return line and running it. And we were hopeful. I was hopeful that it was going to continue to recover control and give it back to the caller, but it's not. So now I'm really wondering what I got wrong in my defer here, because either I have something wrong in my defer, it's not returning control, or something else. Because it's never getting to this line. And instead, the thing I find interesting is that this, I mean, what kind of blows me away in this test, this doesn't make any sense to me. Okay, so why is this returning values? It panicked and recovered from the panic. So I would think that wouldn't be getting anything from it. Could it be in the handoff from parse string? Oh God, if that's it, I'm going to be pissed. I just am, because you know what I'm saying? What if seriously, if that's it, because of the whole macro, because of the whole def, what I have a feeling is that the deferred panic recovery is not propagating up to the caller function, which might be the thing that's disassociating it. Because I swear to God, this was working before, and we had it exactly like this. So I don't think that's it, but let's try anyway. So if I parse a byte string, a byte slice, which is, you know, what this requires, is that going to improve anything? Nope, same thing. So that wasn't it. I just thought that might be, that would have been really surprised if that was it, but that would be so dumb. This is just a type conversion. That's all it is. That shouldn't be affecting anything. But for some reason, again, it's returning nil here. Why is it returning nil? And why is this guy not happy? We already proved that this line doesn't even get run. Never ever gets to this line. I never get here. You see that? See how annoying that is? Even though this one does, this is print. This is the last line of my life. So it's going to run that just fine, see? What? Wait. People. Oh, no, it did that. I have to do it as a printf. This is part of the testing reflection thing that's happening now. So I'll go ahead and do a proper println here. This is the last line of my life. So this is seriously, after this function ends. And since that's the only function called from here, it goes on. And there's nothing to print because these are nil. That's like really bad. The thing that's worse involved in that is all my little explanation about closures is completely bullshit. Because look, this didn't work. That should have recovered. You know what? Let's try something else. Let's make it a local value. I mean, another thing you can do is, this is so people sometimes do, this is going to, watch, this will blow up the whole thing. You can panic P, you can propagate the panic. There you go. And that'll keep it going. So it recovers from the first one, and then it's like, keep throwing it. You can actually change it up and throw a new one and everything. So yeah, and that I mean, that doesn't get us anything here in this case. So the conclusion of this is that that there are lots of ways around this, but they are all complicated and stupid. One of them is that when we do any panics at all, that we communicate, we send something with the panic. The panic can receive one thing, any type of thing, and you'd have to make it so that some of my YT VODs, what keyframe do you use in OBS? I don't know why. The OBS, well, I don't even know what that is. Should I use a keyframe of some kind? Is it a problem? If it's a problem, let me know. Word. How often your text typing updates? Looks great. The VOD's a high variant cost. Well, I don't know. We'll have to go see. I have no idea. I mean, I can look it up for you really quick if you want. I'm sure it's probably one or two. I honestly don't know. I have to go look. Settings. Currently active. Can't change them apparently. Yep. I don't know. I'd have to turn it off for a second. I can find out for you next time. Yep. Output recording tab. All right. I gotta stay on topic though, because this is a tough thing. I don't do recording. I just do streaming. I stream directly to Restream, and then Restream sends it to YouTube, and then YouTube saves my videos. It's live. I don't publish anything. That's the only reason I'm doing it this way. Yeah, I literally push a button and I'm live on every stream, and it's automatically saves my VODs. That was enough of a convenience for me to drop affiliate on Twitch and say goodbye to like $300 a month or so. Because I was like, this is so nice. It's like, I don't have to do anything. All I have to do is just talk and work, and it gets published everywhere. With unlimited transcoding, by the way, which you can't get unless you're a fucking partner on Twitch. Twitch can die for that. That's right, Twitch. You suck. I would even pay for that, but you don't even give us the possibility of paying for higher transcoding for our people. You make us have to work toward partner. And so if we're science and tech and we're not fucking Fortnite, we don't ever get a chance to be partner. So in case you're listening, Twitch, I'm done. I'm doing you because you have a nice IRC interface, and you fuck with that, I'm totally gone. Meanwhile, I don't care. Do you think I care? Twitch can bite me. I mean, they provide a really great service, and they've given me a lot of great, contacts with amazing people, and I'm thankful for all of that. But the way that they deal with their partners and their developers is absolute bullshit. And now they're trying to put advertising, force advertising on people in the middle. They can bite me. Seriously. I would rather, I mean, if they kick me off, I'll just stay on library and YouTube or whatever it takes, whatever I have to. Because people will find me who actually want to learn about shit. The fact that people in science and tech have no additional benefit, that Twitch doesn't give a shit about educational streaming, that they would rather make money off of a bunch of head in their sand, distracted pieces of shit gamers, really angers me. It shows where their priorities are. I'm sorry, it just does. They really don't care about improving our world. All they care about is making money and promoting gaming. I'm not against gaming at all, but the way that they don't give any preference to people who are actually trying to do something good for this world just really pisses me off. Yeah, that's what I'm saying. So yeah, fuck them. Sorry, Twitch. I can say that now. I'm not affiliate anymore. You know what? By the way, you know what they're doing? They're stealing money from my people who can't unsub because they took away the sub thing because I followed their policy. And I wrote to them and I said, please take me down from affiliate. I'm probably like 1 in a billion who actually ask for that as opposed to waiting to get kicked off. And then what? I have people who are still giving me bits and losing money because they don't know better, because they're not warned that they're not supposed to be able to give bits to a non-affiliate, and they can't unsub for me. So I have all these people who are being subbed who are giving Twitch money and can't unsub now because they can't click on the unsub button because their system is so fucked up and broken that their own policies don't work. And now Amazon's got a hold of them, and it's just going to get worse. Anyway, probably time for me to take a nice break. I'm a little bit pissed at this problem that I'm having here because this means that my fears were confirmed in the first place instead of assuaged, which is what I was afraid was going to be. So just to get back on topic here, what's happening is, those money generators, it's all about the money. Nobody really cares about improving our world. It's all about the money at the end of the day. The Invisible Hand, Adam Smith, go fuck yourself. I really hope Mr. Third Industrial Age is true. Yeah, it's insane. I know. It's like they have to send something to Twitch, and so what am I going to do? Sit there and wait on the phone lines forever to help every single person that I've helped encourage to subscribe to my channel learn how to unsub without losing their subscriptions? They can never unsub. You know how fucking horrible that is? That's downright unethical. And they have no problem with that because the number of people who have that situation is so small. It's actually the people who are honest about dropping their affiliate. Yeah, it's total scamming. I look, some of the tech in Twitch was nice at first and everything, and they got me started and I got into my live streaming. I will always be grateful to Twitch for that. But everything I've discovered about them since then is absolute bullshit. It is. It's just absolute bullshit. And it's just all motivated by greed. And they're like, and you're like, yeah, but you're saying this on Twitch and YouTube and you're doing it for free and you're not paying a dime. And why are you complaining? Why you're getting all this stuff for free? Here's the thing. I would actually pay for a good service if somebody provided it. Nobody's offering me the option to pay for something. So, this is why Twit TV became a thing. They're like, oh, we're done with the bullshit. It's why library became a thing, right? So I realize that we have to bow down to the streaming overlords right now and that their motivations are money, but time for me to think about something else. You know what? I'm kind of bummed about this because this means that the only way past this problem I'm having is that, first of all, it confirms that my initial understanding of panic is true. So let me actually do a lot of research on that before I make that conclusion. Maybe I'm missing something simple. Golang recovering from panic to send an error. So they do have an example in here. We were already here. I'm going to go back here. I could have swore we did this, so maybe I'm missing something small. Maybe it's easy. And that will make me happy again, because right now I'm kind of pissed. The reason that I'm doing all of this is I want to use the panic. I want to use the panic approach, the panic idiom for the code generation to keep the scanner simple. In case you guys are wondering, let me just recap. The reason I'm doing all this is because I want to be able to write simple scanner definitions that can be generated from text template when I get to code generation. So here's the definition, right? This definition is a representation of a grammar line item. So in this case, oct digit, right? Or where's the other one? Octal. So octal, right? An oct range, an octal here, right? So a definition is a representation of that. So here we go. Here's an octal. It has its index type, what type, and anything. It's got all the information for the errors and everything. And this is all really going to be essential when I'm doing both real-time evaluation and validation of grammar of text against the grammar, and I'm actually code generating for stuff that needs to be embedded in people's applications that want to have grammars. And so the reason that I went with the panic model is because of this. Look at how pretty this is. Do you see any if, then, else, all that? If, else, if error does not equal nil, this and that? Don't need any of it here. And the reason I wanted to simplify this definition struct for each of these line items in the pegn definition or any definition, so that I can then create a lookup table for real-time evaluation, and which it corresponds with the index number, by the way, and so that you can just use them and enter the scanning and parsing at any moment. This is an extreme simplification of how I did it by hand the first time, which is like got some 90 different parse functions, not to mention some additional 90 scan functions. So this is a really great improvement to the overall architecture and design of this particular package. This is round 2, by the way. Round 1 we already finished, got it all working, and made sure proof of concept is good. There's a couple things in round 2 that are coming that are new. One of them is the whole real-time evaluation, the PEGX instead of pegn, a PEG expression. And that means defining them all in a single definition struct with first class functions assigned to variable struct properties, I guess. So this is all well and good, but when I had all these if statements in here, it was really messing this up, and it was making code generation a lot more problematic. And so I attempted to use the panic. So now any one of these scannerooms or scanmin defs, if they have a problem, they go ahead and panic. And then the callers can trap the panic and do whatever they want. At least I thought. And so what I'm finding now is that if I am going to trap the panic, like I did in the scanner test over here, that I have a situation, right? Because here's an example of me trapping a min-max problem. So all the scanner stuff works. I've tested this all. But see, I have to defer the function, and I can go ahead and print the error here. And this is all well and good. The problem is that imagine you have a function that's encapsulating this function, this whole situation, because you want to return an error instead of propagating a panic, or trapping a panic and doing something with it, and then not propagating it. And that's what I'm facing right now. So the problem I'm facing now is that I'm taught this is a top level function for the package. So you would invoke this by doing pegn.parse, and you would pass in a grammar of some kind like this, representing your language, whatever kind of language you want. Pegn is a meta language, which means you can express other language and parameters in it. So you would be writing, PEGX would be written in grammar, that grammar form, and then the idea is that it would build a scanner, it would parse it out and see, and you get an AST out of that, and that would get added to an expression, which I would then return to you along with an error, which is the idiomatic way to do things in Go. It's not a good form to panic, because panic can kill your app, and you don't want to do that, and you don't want to do that. So it's actually better form to add a must parse, which simplifies your signature strings, allows you to use fluent patterns, so you can use dots to connect all the things together and all of that. But we have a big problem. The problem right now is that I thought that I could get around. See, the problem with panicking is that it's very rudimentary in terms of its scope transfer. So when it panics, when anything goes wrong, so in this case, when this line goes wrong, it panics, and so it starts running these lines. And the first line is it recovers, and this puts the value into P, which is I thought would be a closure, and then it would like. And actually, I think the closure is actually working. I think the problem now is not so much that the closure is not working. I think it is. I think the problem that's happening now is it's not ever returning control to the caller so that it hits the next line. And that's my understanding of how panic has worked in the past. I thought earlier today that was not the case, and then I had discovered something cool about Go, that it had actually transferred control to the caller after the recovery. And that does not happen. So these lines never get executed yet, and neither does this return line. But for some strange reason, it returns no problem, and with nil values, and that's what we got over here, which just really blows me away because, I don't know. It means it's recovering, so it's in some sense it's forcing it to return, even though it's not hitting the return line, and that just really blows me away. So. Yeah, so that's sort of annoying, and I'm trying to get my head around something I may have missed because I'm not a panic expert. I don't do that stuff a lot because of all the reasons I've just everything I've just described to you is the reason that I just don't use panic defer. And frankly, it's probably the reason people want proper exceptions because they allow you to have more finite control over the try-catch blocks and where you return control and all of that. And right now, it's kind of crapshoot. You really don't know when you get control. Obviously, you don't get control back. And if you don't get control back, which is what the tests are proving right now, then I am forced to use, if I'm going to continue to use this model, I will be forced to tell my end users, hey, get ready, there's going to be panics here. And I would really, really rather not do that. I would really rather not do that. I would rather not say that. I would rather have a nice, clean API. And when I say API, I don't mean web API. Web people have kind of commandeered that word. I mean just a way of using my program, that I want a nice clean one that returns an error and doesn't do any panicking at all, so they can be nice and feel happy and safe. As soon as you say in your documentation, oh, get ready, there's a panic here, watch out, and I'm like, oh shit, what else is he panicking on he's not telling me about? How is my application going to die unrecoverably because there's no defer? In fact, it's probably a good idea in most of your command programs to put a defer in your top level logic, like in your command, because somebody somewhere in one of those dependencies you have is going to panic, and you're going to be like, I didn't catch that panic, and your daemon that's supposed to keep running is also going to die, at 4 a.m. on a Tuesday. and you're gonna have to go find it. So it's just good practice to stick a safety, defer at the top level of your code, so that if anybody else has decided to panic and not tell you about it, that you can recover from that and still do other things. The problem is that the panic doesn't give you a lot of fine-grained control about how to recover. So depending on where you trap the panic, like I've trapped it here, it just runs this function. Well, what I was hoping it was going to do is it was going to return control here. And you could start a whole thread of execution again, but then you have to deal with things like, well, so this is some things I've always wondered about. Like, what happens to all the memory that was assigned right here? Did that stuff ever happen? Apparently not, right? So I assume all this memory got freed when it panicked. But I don't know that. I mean, if I had open channels or I forgot to close a channel or something, if panicking scares the shit out of me, because I don't know what's happening when the panic happens. I know that it jumps to this function and starts running, but I have no idea what it did with the resources. And since this, ironically, defer is supposed to be there for you to clean up resources like closing file descriptors and stuff, then, you would go do that. But, let's say I define variables here, right? Well, those are pretty safe, probably pretty safe to say those are not going to be reached. But what if I had some memory cleanup down here, right? That memory cleanup would never happen. I'd have to make sure to put that in the defer. And that just goes without saying. That's why people put all that shit in defer anyway, and that is a strong pattern. Any kind of recovery you want to have happen in this function, make sure you put it very first, then you put it in your defer, so that no matter what, that stuff gets freed. Obviously, variables and walrus operated variables and things like that have local scope are going to be fine. But some of the other types, like channels and things, are a little bit more complicated, and they might not finalize the way you want them to. So that's what defer is all about, primarily, and you'll see that there a lot. And once again, using panic is kind of an anti-pattern, even though it's all over in other stuff. And frankly, this whole experience has kind of made me not like it even further. I was like, oh, hey, look, the encoding JSON library uses panic to transfer control. The encoding JSON library does a lot of other dumb shit too, by the way, like escaping angle brackets for no fucking reason, or escaping Unicode so that kanji characters, which are totally valid JSON data, can't be read because they're all escaped. And so we ended up having to write our own, and I'm just tired of it. So now I'm not thinking, well, maybe JSON encoding package isn't a shining example of, Golang idioms. And since it uses panic for transfer control to keep the scans, pretty, then maybe it's not such a good example after all. So I don't know. I'm kind of getting pissed at panic right now. The thing that's really sad too is how prevalent panic is in all the beginner docs right now. This is an overwhelming concern that so many Go educators have, and they've talked about it a lot and all over the different boards. You can go find them, but they're complaining constantly because all of the beginner examples use panic, and they're like, well, "You guys have got to stop using panic. Beginners think it's okay to use it." And like, well, we never said it was to use them good in production. It was just a way for us to. Well, then stop fucking using it. Because what the beginners are going to see it, and they're going to put it in their code, and they're going to think that their HTTP daemon that they wrote can have panics in there, and it's going to tank their daemon process from running. Because they don't know better, because they don't know all the subtleties of panic. I mean, I've been doing this. I've been coding in Go for 6 or 7 years now, and I use panic so infrequently that I could not even tell you at the beginning of the day today. I had my hunch, right, which turns out to be true, which I hate. I want my hunch to be wrong. That you lose control. You lose control when you panic. You have no further control over what's going to happen. The caller never gets control again. And that's why I never, ever, ever use it. And it's also why I don't understand the intricate details of how it works. And I may actually just banish it from my whole entire project, which is why I'm a little bit triggered right now. Because if I do have to banish panic from my thing, I have two choices if this is all true, what I'm concluding here. If this is all true, I have two choices. I can either throw out my entire beautiful scanner model, which has this nice pretty thing, which is going to auto-generate without a problem. And if I do that, that means all of these things are now going to be reading if statements. If error, I mean, we already did this once, so I know how to do it. It would be something like this. Right, and then it would be this. It would be error equals scanf. If error, then blow up, right? And then I have to do this for every one of these. And this is why I didn't want to do this. And there's a better programmer out there who knows a way around this that I don't know. It's not var equals nil, then bail. Right. And the reason I have to have this is because if I try to get fancy with, another function or something, I'm killing the whole reason for doing this in the first place, which is more efficient code. So, I mean, if I were going to do it like the GoPeg project does, this, you wouldn't even be able to read any of this. This would all be a bunch of go-to statements and 10 levels of nesting. So the whole point of this is to make it clear to read. Well, if I have to add if error equals after every fucking call to any kind of scan, that's not clear anymore. So this is a solid case for using an exception path or, panic. And that's why I gave it a shot. So lest anybody think that I was, motivated by ill intent when I added panic, the intent is to keep it simple. And that's what I did. And frankly, it might mean that I have to, the other alternative to this is to write a disclaimer. I write a big old disclaimer on the use of this package and say, look, this is going to panic like crazy. Any calls to any of these functions will panic. You just need to count on it. And that kind of, deflates the whole standard idiom I told you about, which you see in the standard library, which is to put the word must in front of something, which infers that the thing is going to panic. And then you're like, anytime you use anything with this starts with must, you're like, no, this is going to panic. Which now means probably, okay, so I think I just came up with an idea for myself. This means that in order to infer this, I'm a panic, you better get ready for it, I got to put must in front of everything. So unless I can make this work, this trap that I'm working here on, that means the only entry point to my routine, to my library, will be pegn.must-parse. And they'll be like, what does that mean? Oh, must. Oh, there's a panic coming. Because that's an idiom, that's a pattern that's really, really common in Go. And so developers would see that and they go, oh, okay, this is going to panic. I got to watch out. And I'm glad I talked through this because, you know, that option is really the only option I want to entertain. I'm not going to go put if error equals nil on every single one of those things. I'm just not going to do it. It would make it would defeat the entire purpose of having definitions do function calls in the first place. And, you know, Mac beat me up over not having those. It's like, this is too unclear. I had all of these implemented as, you know, the actual code for scanrune was like written right here. It made it really long and unreadable, but that was kind of the middle road between, you know, a purely unreadable thing and this sort of, you know, super duper readable, but really slow because there's lots of indirection. There's like 1, 2, 3, you know, 3 levels of indirection here that would not be there had I just inlined all of this stuff, which is what any other like grammar generator would do for the sake of performance. But I want to hit that middle place between that and code maintainability so that the generated code can actually be maintained and used by humans, as opposed to being completely 100% permanently dependent on your code generator, which is what Lex and Yak and PEGX and GoPeg and PegLeg and all the other ones do. So that's kind of a recap. I'm really glad I went through that though, because I'm rubber ducking here, I know, but this, I've just convinced myself that under no circumstances will I be returning errors from scan-def-min and all this stuff in here. It's just it's gonna blow these definition templates out of the water in terms of clarity. And the whole purpose of this is to increase code clarity. And I will not trade it. I'll give in on panic before I will make this code unreadable. I just won't do it. So, but the obvious perfect solution, which is why I was so happy until recently, is if I can get it to return caller state, return to me. I want it to get, after it panics and recovers from the panic, I want it to return execution to the caller state, which means I have control over the return values and I can transform that panic trap into a nice, pretty enclosed error message. All right, so when I come back, I'm going to go do a little bit more research into trapping panic. I want to be absolutely sure that there's not already a pattern out there for this. And as I've said, I don't trust my personal mastery of trapping and deferring panics enough to just make an architectural decision right now. This is slowing down the project, I realize it, but it's going to make it much better and cleaner at the end. And hopefully you guys are learning something in the process. I'm going to put the fish on for a bit. And That definitely needs a hotkey set. I should probably set a hotkey for that. What should it be? What should my hotkey for that be? Numpad multiply hotkey. I don't need any of those. Let's do. Wow. Let's do desktop audio, mic audio. Mute and unmute. Let's make it. Does this even register? No. How about. Oh, pardon me. Atlantis. Is this Atlantis the cast? I don't know, man. Let's do this one. Why is this not working? Do I have to click twice? Oh. Apparently numpad plus and unmute. I know, we'll do numpad minus and we'll do numpad plus. What? What the heck? No, this one. There we go. Yeah, it should be numpad. Apply. All right, let's see if it works. All right, I'm talking. I'm going into the red. I'm talking. I'm killing this fly on the TV. I'm talking, and then I'm muting. I'm talking. You know what? I wish it would do that and show me something. Show me the mute. Problem with mute is I never trust it. It's muted. You know what I mean? It's like, I think it's muted. But if you miss, you definitely want to see it. Yeah, I know it works, but I need to make it so it shows it. I need to make a bigger mute, actually, for my whole system. Yeah, I should probably make a sound mute hotkey, which I'll do eventually for all of my sound. I can just push it and like puts a big old thing on my screen. You know, because even like this does not work. And like all these things I have to. This is also why I don't want to re-update my operating system. I've done so many customizations of this thing, and I've documented most of them, but not all. Anyway, we will put you aside for now, and go back to this rather. I really wanted to have better news here. I'm kind of sad, and it's the afternoon, which is when I struggle to stay motivated anyway, because I want to go outside and run or something, which I probably should do, keep my spirits up. So yeah, let's, what's going on with defs? We have an error here we're not using. I think I'm in defs, am I not? Oh no. Defs.go. All right. So I was trying to show that one thing. Okay. So back to the research. Go provides a special function to create a panic interface. It's called explicitly by the programmer to create a panic. It takes an empty interface as an argument. When a panic happens in a program, it outputs two things. An empty interface, by the way, is anything. Stack trace of where the panic happened. Okay, all good. Runtime panic errors. Runtime error in the panic program can happen in the below cases: out of bounds, calling a function, sending a close, incorrect type assertion, blah, blah, blah. That's all well and good. Let's talk about recovery. Call on a panic function explicitly, which is what we are doing. A panic can be called explicitly as when the function expected a value argument, but instead a nil argument was supplied. Cannot continue or raise a panic, which a program cannot continue. Yeah, and this is where the real question is you don't want to use panic unless it's for a case where your program cannot continue under any circumstance. It can't recover with an error. So that's when panic is a thing. And this is the example. They have a recovery. We have a function checker that accepts a slice, and then there's one's out of bounds, and we go ahead and panic. That's fine. That's not what I want. Okay. Defer in main panic with defer panic after panic in F2. See, this wait, let's check this here. Let's see an example. When panic is raised in a function, then the execution of that function is stopped, and any deferred function will be executed. In fact, deferred function of all the function calls in the stack will also executed. Will be until all the functions have returned. At that time, the program will exit and it will print the panic error message. So if a defer function is present, it will be, that's not English. It will be executed and the control will return back to the caller. No, it won't. We just proved that. Please be true. I want this sentence to be true so bad it hurts my body. Back to the caller function will again execute its defer function if present, and the chain goes on until the program exits. All right, so let's see if this is true. Please let this be a stupid error on my part. Please let it be a stupid error on my part. I don't care if the whole world is going to see this. Maybe they'll avoid my stupid errors. Once again, full disclosure, I do not use panic very much because I don't like it. At least explicit panics. I'm dealing with actual panics that come from systems or a thing. Main, defer print ln, defer in main. So when this main function exits, it will always print defer in main. So when it does panic with defer, what it will do is it will print defer in main, and it will not print panic with defer. And then it says here after panic in F2. This is the line that in my code is not getting executed. So if this works, then I'm going to be happy. But I have a feeling it's not. So here we go. Look, output defer in main, which is what we said it was going to do. You know what they did do? They didn't recover the panic. Wait. Oh, it's because wait a second. Are you telling me if I don't recover, this return control? Wait. Main, go routine, blah, 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 exit status 2. In the above program, we have a defer function first, and then we manually create the panic. Yes. As you can see from the output, the defer function got executed as below line is printed in the output defer in main. Yes. Let's understand what happens when panic happens in a program. So it did. It printed defer in main. It did not print panic with defer because that was the interface that was passed in that was ignored, which would have been, we could have captured that with the recovery function, the special function. We're getting ahead of ourselves. So let's understand what happened. So imagine a function called from main function to function 1 to function 2. So main, yeah, this is irrelevant. Execution of F2 will stop. Defer functions in F2 will be executed if present. Control will return to the caller, which is the function F1. I don't believe you. I just don't believe you because I just watched it and it didn't do it. F1 function will behave in a similar way as if panic happened in that function if the caller returned to the caller. Note that if there are more functions in between, the process will continue to stack up. Yep. Main function will also behave as if panic happened in that function. Yep. Crashes will print the panic. So defer 1, panic 1. So defer 2. So where's our main? Main, F1. So it does F1. It defers F2. It runs F2. And when it runs F2, it goes to F2. But before it goes to F2, it runs the defer. No. It should anyway. Oh, because it hasn't left yet. Okay. So it goes to F2. and then defers defer in F2. Panic demo doesn't do the panic because that's the string. It gets past the interface and ignore because there's no recover call. And then it does the defer. It causes it to panic, and so it runs defer.to, which is why it runs it first. And then it returns call to the call stack, which is why this line never gets run. Once again, this line is not ever run. So that returns control of the panic to the function caller, goes back up here, and then it runs after panic F1, runs F1. And then when the function normally ends, it'll say defer in F1. Wait. No, panic demo. Oh, because that's not trapped. Okay, never mind. So the recover is not trapped here. So what that says is it just prints the defer in 2 and returns control back. No, it propagates the panic, which is already panic demo. So then that panics and never gets to after panic 2 because the program panics. All right, so that's what I would expect. Yeah. Any above program panic happen in 2 line below? Yes. Got it all. Recover and Golang. Well, okay, so recover just grabs the interface. So if there's no recover, it will not stop the panic. So the panic will keep working, and you should always recover from the panic. That's just dumb. So yeah, the problem with this is that what happens after the recovery. So it's panic's out of bounds, but then it goes to handle out of bounds. Handle out of bounds recovers from it, and if it's not nil, it just prints, "Hey, I'm recovering." And then what? Then it. But the question is what happens after that. And then this is the question: does it get to FFT println? Exiting normally. So you see what it did? It never got here. Never got here. And that's what we're seeing. That's what we're seeing. So this is confirming my understanding, my initial understanding. So what happens is it goes here, it panics on something, it handles the panic, recovers from it, and then returns from here with nils in here, doing exiting. Wait. Yeah, it returns, but there's no return value for check and print anyway, so that's what's happening. There's nothing return. So then it goes back up here and it does this. That means this line never gets executed. And they better be telling me this down here, I'm going to be pissed. So if the above program, in the above program, we have a function check and print, which checks and prints slice elements and blah, blah, blah. Contains the call to recover. Function also get into panics and print blah, blah, blah. Out of boundary for slice. After the recover function, the program uses the controller returns to the called function, which is in main. This is why we get output as exited normally. It exited normally, but it didn't do the print. It didn't finish that function. The recover function returns the value that just passed the panic function. Therefore, it's good practice to check the return value of the recover function. If the return value is not nil, then panic. Blah blah blah. We know about that. Here, if R is panic, then did not happen. Okay, then just do normal thing. So there are reasons to defer that are not related to panicking, and that's why you should just put in an if statement. Gotcha. That's like given. I know that. Note that if the defer function and recover function is not called from the panicking function, then in the case also panic can be recovered in a called function as well. In fact, it is possible to recover from panic subsequently up in the chain of the call stack. Huh. Let's see an example of this. Okay, this is interesting. Let's see. So check and print with recover. Check and print with recover. Defer handle out of bounds. Check and print. Check and print. Panic out of bounds. So it's going to handle out of bounds. Recovering from panic. R. Out of bound access slice. Okay. And then this line doesn't get executed again. So talk to us about that, oh wise blogger. I'm almost positive I know the answer to this at this point, but I don't want to believe it. The above program is quite the same as the previous program, other than we have the additional function check, which calls the blah, blah, blah. I don't care. Is able to recover from the panic? Yes. But what about this line? Is there any way to recover and have it execute that line? Looks like no. Is not within a different function. It will not stop the panic. Handle out of bounds is not deferred, so that's just stupid. Why would you do that? There's no reason to ever do that. Happening in the same go routine, and it won't stop panic. Okay, that's good to know. Interesting. Actually, that's really good news. Because that go routine, do go routines have different package variables? I think they do. I think the reason, I don't know. I mean, I'm so scared of that, but one very bad way to get around this would be to use a package variable and put the error in there. Kind of like a state, like what state were you working on last? Yeah. Routine 18 running, blah, blah, blah. Printing a stack trace. I don't give a shit about that. Output, no. Okay. Return value of the function when panic is recovered. This is what I'm talking about right here. Okay. So when the panic is recovered, then the return value of the panicking function will be the default value of the return types of the panicking function. Aha, that explains the nil-nil. All right. So that at least explains it. It doesn't make me like it, but it explains it. Because why? Because down here we're getting nil-nil from these two things, even though these lines are never being executed. All right, back to where we were. Let's see the program. Check again, blah, blah, blah. So once again, this never gets executed. Right. And you see here, value D. So it still gets, see, this is what's crazy, is it actually returns a thing, but there's nothing there. And error is nil. See that? Please, please, please. I think they're headed to the right thing. Please let there be a way out of this. I am praying, people. Since check could get create panic, which is recovered with the handle out of bounds function, therefore return check, blah. Therefore, values, because 0 is the default value. Int, yes, got it. No, because nil is the default value. If you don't want to return default 0 value types, wait, this is very important. If you don't want to return default 0 value of types, then named return values can be used. What? What? That is the first significant use of named values in the function signature I have ever heard of. If this is true, and I'm understanding it properly, you never want to use anything but named values in your stacks. Holy shit. I mean, I want to read that, but I'm going to go try it right now. That is insane, people. Do you see what they're saying? That if you define it up ahead of time, that it can be used. This is a seriously big fucking deal. I mean, this is major if this is true. So this means, and that's a massive. Okay, so we had a new expression. Actually, I don't have to do that because it's a 0 value, and so it's already initialized by doing this, which is what that does. And then it sets the AST. And holy cow, wait. Something is different. Invalid memory register pointer recovered. Okay, this is a different error. This is interesting. So, what the heck? So, yeah. Um, yeah. You realize what this means? We can do this. We can do. Oh my god. So I mean, I can make that every. Holy cow! Equals. Oh my god. Oh my god. Please work. Please work. Please work. Please work. The suspense is building for me. Invalid memory address or no pointer. That's a different problem though. This is a totally different problem. So we got a new thing happening that is good. Actually, down here we just have to do a return, and that will give us an X, which has been pre-initialized. The problem is that this right here. Okay, so that's what triggered the problem. So that should be nil, which is what we want. And it's actually getting there, people. It's never getting to these lines, but it doesn't matter. You know why? Because these variables have been predefined, so they've been filled by the time it returns. Yes. Oh my God, that's so cool. Wait. That means if this is true, this means that using named return variables initializes them at a different time than it does when you use them the other way, which is really, really, really important. Because the order of assignment or declaration or whatever is going on is fundamentally, applying to what's available in the scope of the panic, which is really cool. Because that means we can use, if this is true, God, please let this be true. If this is true, that means I can use error as a closure inside of my deferred function, and I can set it in there. I can even put X in there. I can actually have the expression be in here and return it as well. So let me just play with this. There is a different error going on. So let's go work with what that error is. That is insane. If that's true, that needs a blog post all by itself. It's like you didn't think you needed named return variables, but you actually do. Basically, are you using panic? Use named return variables, the end. So, or whatever, return values. Invalid memory pointer or dereference. This is a totally different thing. So what's going on here? So actually, this is what I would expect to have happened. This means, wait a second. Wait a doggone second. This is an example. Octal that's giving us error now. Wait. Is no such thing as parse string anymore? Recover panic, invalid memory address. Parse octal. Test line 10. Why are you having trouble? Oh, wait a second. That had a problem. Wait, that doesn't make any sense. This does not make sense. It should have printed it just fine. That means it wasn't assigned. That means it didn't do the parsing, which is a totally different problem. Holy cow. It fixed the other problem. You seeing that? You seeing it? It did it. It fixed it. It fucking fixed it. Okay, so that is awesome. So invalid memory address or no reference, runtime error. So you know why? Okay. That's actually that's just my debugging stuff blowing up. So there's no error to print here. Right? Oh wait, we need an if here. We say if p does not equal nil. That'll unblow that up. Invalid memory reference. Where does it give me that error? Indefer runtime error. Invalid memory reference. Invalid memory reference. What? I gotta get rid of all this crap. Time for me to clean it up. I can't believe that's gonna work. Oh, did you see that? My other test passed. Yep. This test passed. So, the moral of the story is all your stuff about closures and everything does work. You just have to set it as a named return variable or value. That can't be that simple. Oh my God. And that's the first time I've ever learned about that. That is also the first time that I've ever considered a real need for named return values. Otherwise, it's just a convenience that people don't like to do. It's really ironic because I just read a blog from a Go person who's relatively informed. He's like, I actually really don't. There's a book actually. He's like, I really don't like using named return values because they suck and they're not really clear to read. I'm like, well, now I just know how much you don't understand. Like me, I didn't understand it. So the end. I don't need to even make P a closure anymore because why? Because I can grab the error out of it and make one right there and return it in the variable because the symbol was embedded as a closure for the return value. Oh my God, my brain just exploded. Oh, that is so stinking cool. I have to blog that. Somebody, well, I just made a video about it. So I spent like 2 hours explaining this. For the few people who actually watch this video, they'll be like, oh my God. Yeah, I need to this is where I wish I could bookmark videos and clip and stuff for the YouTube. I might actually have to do that in my notes, in my description notes. And go to the video and do one of those liner notes things. Just cause, or maybe somebody else could do that for me. Invalid memory address pointer. This is a different error entirely. So we fixed one problem and got another one. But yeah, I am so pleased by this. Can I just say, this is so happy. I was ready to write it off and say I had to put must in front of everything. You heard me, right? And now the light of the sun is shining again. And Go has restored my faith in it. How would you have known that though? I mean, come on, that is the most esoteric, weird little thing. It's like reading the whole bash man page to learn that CD path and it exists, or bash completion even, tab completion. So invalid memory address or nil pointer reference. This is another error, which is not important. But I still need to make sure that I get to it and I understand what's going on. There's something simple and small here that's happening that I don't. It's not a big error. I hope. Knock on wood. Knock on wood. It's not a big error. Wow, I'm so pleased by this. Okay, well, this obviously broke. So the octal one broke, but the other one got fixed. So let's fix what I broke. So parse string. Oh, you know why? You seeing this, people? Can you see why? Boys and girls? Can you see why? Oh, I think I know the reason. Because look, these aren't named. But I don't think I should have to name this one. This is a new thing though. This is some interesting science going on here. Actually, I know I have to name this one now. Because I'm going to be returning that thing. So that's good news. And I probably finished reading that page, which is going to explain what's going on here. But I want to fix my error first, and then I will read it as a cathartic reflection moment. All right, so parse. Invalid memory address and input reference. No, it's not. P does not equal nil. Where am I getting the error? You know what? I should just let the panic go. I'm going to let the panic go. I'm going to release the panic. Release the panic. You know what? I'll just propagate it for now since I don't want to break my code. Panic. I'm going to pass on the panic. Violent coach. Okay, so where is it coming? You're going to tell me it's inside the panic, aren't you? Yes, you are. Line 21, which I know. Where before there though? Def test line 9. Example parse pegn-go line 30. Okay, here we go. Def test line 9. Okay, so for some reason, no, that's it. That's a different thing. We shouldn't have to do that. That forced the good one to error, and we don't want that. So I honestly don't know what's happening here. Invalid memory address or nil pointer reference. It's in my good test. Someplace in here is not happy. Let's see if we can get that just to panic by itself. No, PEGX declared. How about this? FMT. I mean, I hope it's just a tiny thing. God damn it. Okay. PEGX. Why are you giving me an error? Okay, because it got an error, actually. So this means the parse string had an error. No, it should have parsed that no problem. So what's up? Gotta go spelunking. So AST x equals AST reparse. Parse S. Did it I wonder if it didn't make a new one. I wonder. Oh, it didn't. It didn't. It doesn't initialize it when you do the signatures. I see. Okay, so that's what changed. I need a new EXPR. Yep, that was it. So even though I put the name up here, I still have to initialize it, otherwise it's just a null value. Lesson learned. All right, thank you for teaching me the ways. Thank God for strict typing, right? And this should now be correct except for the scan error, which we know is a problem. I am an expression, but I bet if I do AST now, it'll work. Yep, there we go. But now my other one broke as Bork. My other one is Bork. This should be nil. Yep, there we go. And these tests have to change. I need to do something better with that. I'm going to actually add a stringer interface for PEGX for expression, pegn expression. I call that success, people. That is my definition of success for today. And I shall now read the rest of that summary about how defer and panic works. The major takeaway that I just learned the hard way was that nothing gets enclosed inside of the defer function except for the named return values of the function. I'm going to say that again. Nothing gets enclosed in the defer function except for the return values of the function. If you have a defer, you should always have named, unless you're closing out, if you're using a panic anyway. Because why? Because if you don't have that, you're going to get this mysterious return values, which are just the default values that doesn't make any sense because the lines following the panic are not executed. They're jumped over. So apparently the way Go works is if it is in your function signature, it is therefore available to be embedded as a closure within your deferred functions. That is big news to me, and I guarantee you that's big news to most Go developers out there. Most, run-of-the-mill Go developers who are just like writing return functions and HTTP processes and microservices and stuff probably have no idea that adding a named function. I know so because I read books that say it's immaterial, this is a waste, and it's just a bother to read. And now we know for a fact there's a very significant reason to name your functions your return values. So I'm going to finish reading that little thing here. It says since check and get create PEGX, which is blah blah blah. This is what we just read. The return will be the default value of its types. And then this is the magical line that I read that made it all come true. If you don't want the default 0 values, then named return values can be used. And that's what we want. Let's see a program for that. And then they show us one. We just did one too, but so here they added the name values and the defer. Oh, that's interesting. The handle out of bounds. I don't think the handle out of bounds has visibility to value here. So value equals blah. Value equals 10. Error equals nothing. So value equals 10. Okay, so that's what we also saw. Same as previous, the only difference is that we are using the named return values. Gotcha. Don't need further explanation on that one. Conclusion, this is all about panic and recover and going. Hope you have a little article. Okay, so it's not perfect, but it gets us through most cases. This means that if you have something significant enough to deal with in your deferred functions, first, there's a couple of rules here. If you want to mess with the return functions of the return values of a function that panics, the function must be an embedded enclosure within the function itself. And the reason for that is because you need to reference the enclosed variables, which are also return values, inside of the defer function, and that is not possible in a separate function. So if I were to put a defer handle whatever, that would be, the function would be outside of the scope of this internal function, and therefore these return values could not be used as enclosures within function. The moral of the story is this: use named return values if you have to recover from a panic and control your return values. And you can use those named return values as enclosed variables within your your recovery function. That's like a really huge lesson. I hope everybody gets a chance to hear that, who's ever dealt with this. It also enables everything that I was dreaming of to still come true. And I don't need must. If I want must, I can have it, but I don't need it. If somebody actually, the only reason now that somebody might want must is so they can do fluent pattern with dots at the end, like people use for compile. That's going to be a good place for me to break today, because I'm going to end on a high note. I do have another little tiny scan function error I need to fix here. I'll be working on those while I do my other things today. What time is it? Yeah, I've got a couple hours left. I'm going to go ahead and do some cleaning in my room here and move on. But I consider this a really big success on multiple fronts, even though it just incrementally only pushed me a little bit further along. But my tests are working now, and I mean, this test is not working because it's doing what I want to check it. But I've got solid confirmation that managing return values, even with the panic paradigm, which is going to make simpler scanner generation possible, that's all a thing, and that's all going to work. So for those of you who are still with me, thank you for watching. I really appreciate you guys hanging with me. I thought I was good at Go too. Isn't that funny how that works, right? And so hopefully you guys can all, experience some of this learning with me as we go, and we'll move it forward. All right, take care. Bye.